Cek, cek. Kepada seluruh panitia, Icateas dan Snitp, kita briefing dulu sebentar. Dimohon kepada seluruh panitia, Icateas dan Snitp, kita briefing dulu. Please. Ayo. Panitia. Firman.
Oke. Cek, cek, cek.
Oke.
Cek, cek. Oke. Boleh minta tolong dinyalakan lagi bumper yang awal? Saya pengen tahu lagi. Oh, atau begini. Ini berarti ya ending musiknya, Mas? Oh, oke. Oh. Ini. Nggak ada lagi. Oke, Mas boleh minta tolong dicoba lagi? Bumper. Ladies and gentlemen, welcome to the first Icateas and the sixth Snitp opening ceremony. Assalamualaikum. Oke, I get it. Terima kasih, Mas. Cek, cek, cek. Ini sebenarnya buat siapa ya? Aku naik sebenarnya tadi.
Cek 1 2. Podium. Cek 1 2. Selamat pagi. Cek 1 2.
Surabaya adalah
Cek
organisasi
1 2.
pendidikan dan penerbangan di bawah naungan Kementerian Perhubungan
Assalamualaikum.
yang memberikan
Cek
program
1
pelatihan di
2.
bidang keselamatan penerbangan
Cek
sipil
cek.
dan rekayasa.
Cek 1 2.
Program studi di Politeknik
Assalamualaikum
Surabaya,
warahmatullahi wabarakatuh.
Teknik Listrik Bandara,
Cek selamat
Teknik
datang.
Navigasi Udara,
Cek
Teknik
cek.
Pesawat Udara,
Assalamualaikum. Tambah dikit mas.
Transportasi Udara, lalu
1 2 3.
penerbangan.
Assalamualaikum warahmatullahi wabarakatuh. Selamat datang. Cek 1. Oke mas. Kunci ya.
Lulusan yang kompeten di bidang penerbangan serta mampu bersaing secara nasional dan global. Adapun misi Politeknik Penerbangan Surabaya diantaranya menyelenggarakan pendidikan vokasi di bidang penerbangan sesuai dengan standar kompetensi
Cek 1 2.
maupun internasional.
Moderator cek 1 2. 1 naikkan dikit mas.
Perkembangan ilmu pengetahuan
Cek 1 2. Selamat datang. Cek 1 2. Cek 1. Dikit lagi.
mampu mewujudkan visi
Selamat datang. Cek kunci mas.
dan mewujudkan Tridharma perguruan tinggi serta menyelenggarakan dan mewujudkan profesionalisme guna pengelolaan keuangan.
Narsum tambah lagi mas. Cek 1 2. Cek 1 2. Narasumber. Cek 1 1 2. Narasumber. Cek tambah dikit lagi naik. Cek 1 2. Cek 1 naik lagi mas. Cek 1 2. Cek cek tambah dikit lagi. Cek 1 2. Selamat datang. Cek. Selamat pagi. Cek 1. Oke cukup. Kunci.
Ya. Oh, tidak. Saya hanya pakai ini aja.
Oke, terima kasih.
Kepala BP.
Cik cik. Cek 1 2 cik cik.
Oh, cek cek 1 2. Cek 1 2.
Cek, cek, cek.
Di sini aku
Cek. Cek. Tes. Cek.
Oke. Kami ucapkan selamat datang kepada Kepala BPSDM Perhubungan. Selamat datang pula kepada Kepala Pusat PSDM Perhubungan Udara. Selamat datang di Gedung Serbaguna Poltekbang Surabaya kepada anggota Dewan Pengawas Poltekbang Surabaya serta seluruh kepala UPT di bawah lingkungan BPSDM Perhubungan. All right. Well, ladies and gentlemen, may I have your attention, please? Our opening ceremony is about to begin, so you may have seated. Thank you very much.
Recording in progress.
Ladies and gentlemen, welcome to the first Icateas and the sixth Snitp opening ceremony. Assalamualaikum warahmatullahi wabarakatuh. Again, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to Gedung Serbaguna Politeknik Penerbangan Surabaya, we proudly present you the first Icateas, the first international conference of advanced transportation, engineering, and applied science 2022. May I have your round of applause? Thank you. So ladies and gentlemen, this conference is going under the theme Technology and Innovation Research Enhancement for the future of global smart transportation. But not only that, today we also present to you the opening of SNITP, Seminar Nasional Inovasi Teknologi Penerbangan, under the theme Kolaborasi Kreatif Digital dan Industri Teknologi Transportasi Udara. So first of all, let me introduce myself. My name is Firda Brilianti, and it's truly honor for me to be your master of ceremony for today's event. Alright, so ladies and gentlemen, over the next few days, actually today and tomorrow, we will provide you plenty of discussions, opportunities to share your knowledge and insights. But before we proceed to the program, we would like to greet and welcome Your Excellency, Kepala BPSDM Perhubungan, Dr. Insinyur Joko Sasono, Master of Science. Good morning, selamat pagi Bapak, Sugeng Rawuh di Surabaya. Secondly, warmest welcome to the Head of Civil Aviation Human Resource Development Center, Dr. Insinyur Heri Sudarmaji, DAQIA. Good morning, sir. And the third, the Director of Surabaya Aviation Polytechnic or Direktur Politeknik Penerbangan Surabaya, Mr. M. Andra Aditya Warman, Sarjana Teknik, Magister Teknik. Selamat pagi. And then we would like to welcome our keynote speaker today. We have Mr. Muhammad Aziz, Dr. Engineer, as the Associate Professor of Institute of Innovative Research, Tokyo Institute of Technology, Japan. Hello, sir. Where are you? May I know? Okay, hello. Welcome to Surabaya. And I would like to say hi to our keynote speaker. There is now virtually from Zoom. We have Professor Hendra Hermawan, PhD, as the Professor, Department of Mining, Metallurgy, and Materials Engineering from Laval University, Canada. Hello, sir, virtually. And the second of all, we have Professor Taufik as the Professor of Electrical Engineering, Cal Poly State University from California, United States of America. Please, may I have a round of applause for our keynote speaker today? They are all incredibles. Thank you very much. And of course, to all the honorable and distinguished delegates, the participants, and all distinguished guests. Before we begin to proceed to the next program, let's pray together. And the prayer will be led by Mr. Iwansyah, Sarjana Sastra, Magister Pendidikan. For Mr. Iwansyah, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Before continuing our next sessions, please let me pronounce this prayer for the safety of our 2 days agenda. This prayer will be recited in Islamic way, and for those who are non-Muslim, please do adapt. Ya Allah, Ya Rahman, in this happy moment, we are here for attending our special international event of Icateas. Let us express our sincerest gratitude to Allah Subhanahu wa Ta'ala and His Messenger, to the Prophet Muhammad Sallallahu Alaihi Wasallam, for the opening of our first international conference of advanced transportation, engineering, and applied science. Therefore, we ask your blessing for making these 2 days event as our important moments for our future. Ya Allah, Ya Karim, we know as human beings, we always make mistakes. Hence, we ask always your forgiveness. Please take us away from this sin we are probably unaware. Ya Allah, Ya Khaliq, You are the only God who can guide us safely to perform our duties well. Let this event become something important where we can absorb the knowledge better. We ask You for this international and national event continue annually. Ya Allah, Ya Ghaffar, we know we are the sinners. Please forgive for our sins. Please show us to the right path of our life and give us an easiness to do so. In this beautiful day, we beg for Your mercy. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Walhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Irwansyah. And ladies and gentlemen, before we proceed to the next program, we would like to present you a very, very special performance from Sanggar Tari Gito Maron. Please welcome Lung Kembang Dance. Please give a round of applause for our performance from Lung Kembang Dance. Thank you very much, the incredible dancers from Sanggar Tari Gito Maron. All right, ladies and gentlemen, without further ado, please let's sing our national anthem, Indonesia Raya. Ladies and gentlemen, please rise.
Di sana
Mars Perhubungan. Thank you very much, ladies and gentlemen. You may have seated. Kami ucapkan selamat datang kepada Bapak Nur Priyanto dari LAM Teknik. Kami juga ucapkan selamat datang kepada Bapak Leni Iriairi yang sudah hadir berkenan di Surabaya, tepatnya di Gedung Serbaguna Poltek Bank Surabaya. Kami juga ucapkan selamat datang kepada selanjutnya yang terhormat Bapak Muhammad Mukhlisin dari Politeknik Negeri Semarang, serta Bapak Martios Alius dari CV Mitra Sakinah Konsultan. Selamat pagi dan selamat datang Bapak di Poltek Bank Surabaya. Alright, ladies and gentlemen, distinguished guests, without further ado, please welcome the welcoming speech as well as the official report from our chief or head of committee of today's event. She is Mrs. Siti Julia Sarjana Sastra Magister Humaniora. For Mrs. Juju, time is yours.
The official report of the First International Conference of Advanced Transportation, Engineering and Applied Science Icateas, and the Sixth National Conference of Aviation Innovation Technology SNITP 2022. First, Management Basic. The Decree of Director Surabaya Civil Aviation Polytechnic number SK 305/poltekbank.sby.2022 on 4th of April 2022 over the creation of committee team for the first international conference and the sixth national conference. Second, the goal of seminar. Under the theme of international conference is Technology and Innovation Research Enhancement for the Future of Global Smart Transportation, and the theme of national conference is the collaboration of air transportation technology for creative digital industry. This conference aims for improving the knowledge of participants on renewable energy, power system, electronics, control system, mechanical engineering, integration and transportation management, intelligent and sustainable transportation technology, multimodal transportation and logistics, and vocational education. Third, the participant. The participant of this international conference, Icateas, is not only followed by lecturers and researchers, but also the university students. There are 57 participants comes from domestic universities as well as international ones. There are 11 lecturers at the first author, 14 lecturers at the second and the third authors. 22 papers have passed the editing review process to Atlantis publisher. 57 authors will be invited to present their scientific paper at Icateas. Meanwhile, there are 258 papers have been submitted to National Conference, the 6th SNITP. 17 papers are submitted by the alumni of Poltek Bank Surabaya. Fourth, the speakers. Politeknik Penerbangan Surabaya has invited the professional speakers on their fields. The keynotes are of international conference from Tokyo Institute of Technology, Cal Poly State University, California, USA, and Laval University, Canada. The keynotes of national conference are the Vice President Information Technology of Citylink Indonesia and the head of Indonesian Transportation Society, Gajah Mada University. Fifth, Seminar Ju. The conference takes place in Civil Aviation Polytechnic of Surabaya on Thursday, 20 and 21 October 2022. That's all the report for the first international conference Icateas and the 6th national conference SNITP 2022. Then we would like to ask the Honorable Head of Transportation Human Resources Development Agency for giving his guidance as well as officially opening the first international conference and the 6th national conference. Surabaya, 20 October 2022, Committee Chairman, Siti Julaiha SSM Hum. Thank you.
Thank you very much, Mrs. Juju, as the head of committee of today's event. Ladies and gentlemen, distinguished guests, excellencies. Next, I'd like to invite Kepala Badan PSDM Perhubungan kepada yang terhormat Dr. Insinyur Joko Sasono, Master of Science. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita. Om Swastiastu, Namo Buddhaya, salam kebajikan, salam kebangsaan, salam Pancasila, salam sehat, salam prestasi. The honorable speakers, Professor Hendra Hermawan from Laval University, Canada, the Honorable Professor Taufik from Kalender Polytechnic State University, USA, Honorable Dr. Muhammad Aziz from Tokodai, Tokyo Institute of Technology, Japan, distinguished guests, especially Bapak Untarto Wibowo, member of advisory body Poltek Bank Surabaya, also Professor Agus Taufik Mulyono, the President of Indonesia Transportation Society, my colleagues, officials, lecturers, directors in the Ministry of Transportation, as well as cadets, Taruna Taruni, and also the participants. First of all, I would like to ask you to pray to Allah Subhanahu wa Ta'ala, the God Almighty, for His blessing that we could attend this very prestigious forum, the seminar, international conference of advanced transportation engineering and applied science, and also the national seminar inovasi teknologi penerbangan yang ke-6. I'm sorry, I would like to deliver my speech in Bahasa Indonesia because my Bahasa Indonesia is better than my English. Yang saya hormati hadirin sekalian yang berbahagia, Kementerian Perhubungan melalui Badan Pengembangan Sumber Daya Manusia Perhubungan konsisten untuk terus mendorong peningkatan penelitian di dalam meningkatkan kemampuan dan juga pengetahuan para periset di dalam lingkungan Kementerian Perhubungan, khususnya dalam rangka bekerja sama dengan komunitas-komunitas baik secara regional maupun secara global. Saya berterima kasih kepada para pembicara yang telah berkenan untuk menyempatkan menghadiri seminar atau konferensi ini. Tentunya kami sangat berharap bisa mendapatkan pengetahuan dan juga lesson learn yang nantinya bisa kita terapkan di Indonesia. Kita berharap bahwa dengan forum seperti ini tentunya akan memberikan suatu kegairahan, energi di dalam rangka kita meningkatkan kemampuan kita dalam rangka kita berkontribusi di dalam bidang kita untuk kemakmuran dan kesejahteraan masyarakat pada umumnya dan untuk peningkatan transportasi pada khususnya. Di dalam event-event seperti ini saya juga mohon kepada kawan-kawan dari BPSDM berperan aktif dan juga secara proaktif melakukan upaya-upaya kolaborasi sebagaimana tema yang diangkat di dalam interkonferensi ini. Dengan demikian forum ini akan menjadi forum yang sangat berharga dalam rangka membangun keberagaman dan juga membangun kemajemukan pengetahuan kita dalam menuju tujuan yang sama, meningkatkan transportasi sebagai alat kemakmuran dan alat kesejahteraan. Saya mengucapkan terima kasih kepada organizing committee yang telah bersusah payah agar acara ini bisa dilaksanakan. Dan saya berharap pada semuanya yang hadir bisa memberikan kontribusi dan juga bisa memberikan makna yang positif dalam forum event ini. Oleh karenanya saya ingin menyampaikan apresiasi yang sangat tinggi kepada berbagai pihak yang telah dengan sungguh-sungguh melaksanakan dan juga memberikan kontribusinya. Untuk itu dengan mengucapkan Bismillahirrahmanirrahim, seminar internasional The First Icateas dan seminar nasional The Sixth Snitp tahun 2022 Politeknik Penerbangan Surabaya secara resmi saya nyatakan dibuka. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om.
Waalaikumsalam warahmatullahi wabarakatuh. Bapak Joko Sasono berkenan untuk tetap berada di atas panggung. You may remain on the stage. And I would like to invite Kepala Pusat PSDM Perhubungan Udara, Mr. Heri Sudarmaji, as well as Kepala UPT. Maksud kami Direktur Poltek Bank Surabaya untuk juga mendampingi Bapak Joko hit the gong to officially open the first Icateas and also Seminar Nasional Inovasi Teknologi Penerbangan. On the count of 3, okay, together. All right. All the photographers. All right, so on the count of 3, can we say it together? 3, 2, 1. And the first Icateas and the sixth Snitp is officially opened. Please give a round of applause. Okay, please remain on the stage for 3 of you, sir. And we will have a photo session together. All right, please come to the center of the stage. Alright, boleh mohon izin dibuka maskernya juga kah? Sebentar. Baik, thank you very much. Alright, 3, 2, 1. Alright, this is a signature pose, right? For the aviation family. Alright, thank you very much, Sir Bapak Joko. And please, the next is photo session with the delegates or with the participants. So you may remain on this spot. And all of the documenters, photographers, you may get a place on the stage. Okay. So please Bapak Joko, Pak Heru dan juga Bapak Andra untuk ada di tengah berdiri. Iya. Inggih. Begitu ya. Oh begitu, maunya di tengah. Siap, monggo. Langsung bisa berdiri bersama dengan kawan-kawan juga diikuti oleh seluruh participants. Alright. We will have a together photo session today. Please, ladies and gentlemen, you may rise. The photographer will take our picture together from up here. Okay. On the count of 3, all right. 1, 2, 3. Again. Take off. Pose. Right. Okay, thank you very much. You may have seated. Please back to your nice seat. So, ladies and gentlemen, now we will have a very brief event, and today is our main program. But beforehand, we would like to say thank you very much to Kepala BPSDM Perhubungan. Matur nuwun Bapak, terima kasih banyak sudah hadir di Poltek Bank Surabaya. Terima kasih sekali lagi. Please give a round of applause to him. Terima kasih banyak Dr. Insinyur Joko Sasono, Master of Science, for coming to Poltek Bank Surabaya today. Okay, so without further ado, we will have our main event. Before we proceed to the next program, I would like to say hi, warmest welcome to General Manager of Angkasa Pura I Juanda. Selamat datang. di Poltek Bank Surabaya. Also, we would like to say hi as well to all the participants of the seminars. Maybe some of you are from outside of Surabaya. May I know? Is there any of you who coming from outside of Surabaya? Please raise your hand, maybe? No? Okay, thank you very much for coming. All right, so next we will have our main event. And beforehand, I'd like to introduce you to our incredible moderator. He is an experienced instructor with a demonstrated history of working in the aviation industry. He is Mr. Ahmad Bahrawi, Sarjana Ekonomi, Magister Teknik. And for your information, he is now head of Education Division of Civil Aviation Human Resource Development Center. He was also a director at Makassar Aviation Polytechnic, Air Transportation HRD Center, Ministry of Transportation Indonesia. And for his education background, this is the special one. So he was graduated as the Advanced Master in Air Transport Management, French Civil Aviation School or ENAC, Toulouse Business School, France or Perancis. So, without further ado, please welcome Mr. Ahmad Bahrawi, Sarjana Ekonomi, Magister Teknik.
Check. All right. The honorable speakers of these seminars, the honorable guests from the aviation industry, and also distinguished speakers, cadets, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to all of you. I am delighted to be here today and very pleased to see you here and welcome you to the first International Conference on Advanced Transportation Engineering and Applied Science, Icateas 2022 seminar. On this occasion, I will moderate the discussion sessions, and we are here today with our three distinguished speakers who are very experienced in their fields. They will share their knowledge, experience, and also insight about technology and innovation research enhancement for the future global transport, for the global smart transportation. Okay, without further ado, I would like to introduce the first speaker. Okay, he is Dr. Hendra Hermawan. He holds the bachelor degree and master in materials engineering from the Institute of Technology of Bandung. He received the doctor degree from Laval University in materials engineering. Currently, Dr. Hendra Hermawan is the associate professor at Laval University. Good morning, Dr. Hendra, or good night at Montreal, Canada. Bisa dibantu untuk soundnya? Can you hear my voice, Dr. Hendra?
Yes, very clear. Yes, I can hear you.
Okay,
Can
c'est
you
bien,
hear?
merci. Merci beaucoup, docteur.
De rien.
Okay, Dr. Hendra Hermawan is active in various organizational activities and also guides students of master and doctoral programs. His research area is generally in the field of metallurgical and materials engineering and has been published in seminars, journals, books, and also book chapters. And today, he will share his knowledge with us regarding the aircraft corrosion. Okay, ladies and gentlemen, please welcome our first speaker, Dr. Hendra Hermawan. Dr. Hendra, the time is yours.
Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody in Surabaya. I'm very honored to be part of this Icateas 2022. Thank you so much, Bu Siti Julaiha, for the invitation. I would like to greet some people I've met before, among other Bapak Dr. Heri Sudarmaji, Kang Profesor Muhammad Aziz, and Kang Profesor Taufik. Happy to see you in this great forum. And to all other attendees, nice to meet you. Enchanté. So tonight, this morning, I would like to introduce you to aircraft corrosion, a problem out of thin air. One of major problem in the aviation that may deteriorate our very expensive investment. Here I show you an image of Air Canada Airbus 330 about to land in Canadian soil during winter. So next time, one day, if you visit Canada in January to March, Canada will greet you with a lot of snow. And where am I currently? If I take the fastest route from Jakarta, I will get on board on, for example, an airline till Tokyo. It takes about 7.5 hours. In Tokyo, I might see Kang Professor Muhammad Aziz. And then from Tokyo, continue the flight with Air Canada, for example, for 12 hours to reach Montreal. And from Montreal to my university, we can take either bus or drive a car for 2 to 3 hours. And then you will arrive in Quebec City. So currently we have 15,000 kilometer different distance. We have 12 hours time difference, but currently it's still 11 hours. Next week it will be 12 hours. And then we may have temperature difference up to 50 degrees Celsius in January, February. So once you reach Quebec City, please visit my university. And you can find me in this building, in this room number. Okay, just knock this room number and you will find this guy. Right. Corrosion from the earth returns to the earth. That's the summary of corrosion I can tell you right away. How can it be? So let's go back to the first image of Airbus 330, where this Airbus 330, this big airplane comes from. Actually, it's come from the earth. Okay, the main construction materials of an aircraft till today is aluminum alloys. And aluminum alloys come from this bauxite or ores, okay, from this sand, red sand that contain bauxite. This bauxite will be treated by some metallurgical technique, to extract aluminium, and this aluminium will be formed into different shape, etc., including these aluminium rolls. And from aluminium in different shape, we will construct an airplane. So we introduce a lot of energy from bauxite ores until this Airbus A380. We introduce a lot of energy, meaning that the materials in the form of aircraft right now, it has a lot of energy inside, and it is not the best condition for these materials. It always wants to return to the lowest energy possible. So from this airplane, from the form of this airplane, the material will return to its original state, releasing energy that has been forced to be inside. For example, through the interaction with the environment, in this case through the degradation process by corrosion mechanism, releasing the energy and then becoming scrap like this, and eventually we will bury it in the earth. So from the earth returns to the earth. You see this flying giant still, Airbus 380, the biggest airplane humankind ever made. It takes 7 years to develop the materials to build this giant airplane. We need new materials because it is now so huge. We need material that has high performance in terms of statics and damage tolerance. So the Airbus and Alcan in Canada and in the United States form a team to work in materials development. If we divide the materials to make this airplane by weight, we will see that 61% is aluminum, 22% composite, 7% others, including maybe the leather, etc., for the seats, plastic, 5% titanium, 5% steel. Okay. For example, for the fuselage, we use aluminum alloys of different class, okay, for different elements. The same thing for the wings. We use different type of aluminiums for different kind of elements in the wings, like spars, ribs, stringer, etc. Why aluminum? Why aluminum alloys? There are three main reasons. It's strong, it's lightweight, it's corrosion resistant. So the strength of aluminum alloy can reach as high as that of some steels. For example, the series 7075 T6 can reach a strength as high as 500 megapascal. It is like twice of the strength of the steel we use for concrete reinforcement. Okay, and then lightweight. It's very light compared to steel, 1/3 of steel. It is corrosion resistant because of the formation of this aluminum oxide passive film, and this film can be thickened, can become thicker by the process known as anodizing. So if we compare again with steel, you can see that aluminum has much better electrical conductivity. It is good for airplane. It has high thermal conductivity. It is good also. So when an airplane cruises in very high altitude, the temperature can reach minus 40 degrees Celsius. So we can, with aluminum, we can release the cold temperature to the surrounding. It has very low density and it has high machinability. So easy to form, to various shape required for airplane construction. And then when we return to the composition of materials in Airbus 380, we see also 20% composite. Okay, let's take example of Airbus 320 versus Airbus 320 Neo. AirAsia, I think, has this kind of airplane. If you see the diameter of the engine, the Neo's one is bigger. The bigger the engine, the more efficient it is. How could it be? With the bigger diameter, we can have higher bypass ratio. Okay, but bigger engine means bigger or larger fan blade. So if we increase the radius of the fan blade, we will increase the centrifugal force, meaning that we will need stronger materials. Okay? If we use titanium alloys, of course we can improve the strength, but it will need thicker plate to make it, meaning it will be more weight to add. But in order to reduce centrifugal force while increasing the diameter of the fan blade, the length of the fan blade, also maintaining the high angular velocity, the RPM, we need to reduce the mass. How can we reduce the mass? Change the materials from titanium alloys to composite. For example, in this case, composite of carbon fiber and epoxy resin, still by using titanium alloy as a leading edge. And composite is lighter than titanium alloy. So in this case, composite improve efficiency of the engine by reducing the weight, by increasing the diameter of the engine, increasing the bypass ratio. And then there are titanium and super alloys. These are very strong metals that can withstand high temperature and high pressure. So we employ these materials in different sections of jet engine. For example, for the engine shaft, we use maraging steel. So steel is still in use for aircraft construction, especially in engine, because until now, there is no other material can replace maraging steel that can be so small but very, very strong. In high pressure compressor, for example, we use titanium or super alloys like Hastelloy X. For the combustor, the hottest section of the jet engine, we use super alloys of cobalt base like Highness 188. So different kind of super alloys used to build the engine. So now we know the main material we use for constructing an airplane: aluminum alloys, composite, titanium and super alloys, and some steels. Now, as I introduced in the beginning, to the materials from the earth to the airplane, we introduce a lot of energy, and during the use of this material in form of aircraft, the material will always want to come back to its original state as minerals, releasing energy. And this process of the interaction with the environment is basically corrosion process. And there are so many reports that relate corrosion to aircraft incidents. For example, One of the famous one is the incident of Aloha Boeing 737 that flew from Honolulu to Hilo Airport. What happened? This is what happened, that part of the fuselage skin just ripped off. Why it happened? It is because of fatigue damage initiated by corrosion. This is what happened. So corrosion accelerated fatigue of the fuselage skin panels. That happens like this. Okay. So there is a accumulation of expanded corrosion products within the panel joints, within the rivets, that leads to a pillowing mechanism, and then the joint surface separated, and then the whole section in this fuselage just ripped off and flew away. There are many other examples of corrosion-related incidents. And understanding corrosion, the operator will take precautions. So during the COVID pandemic, during the peak of the pandemic, many aircraft just stay or were not used, and to store them in a secure place, they store the airplane in dry area like desert, okay, like this one, maybe in the South Spain, some in the desert of Australia, some in the desert of the United States. Why we keep them there? Because in this area, the humidity is very low. Maybe a factor of wind also very low. So we don't need to do periodic check in terms of removing moisture from the airplane. Because corrosion is actually an electrochemical process. So electrochemical reaction involving the oxidation of, for example, in the metal, this metal aluminum, okay, from aluminum metals to aluminum ions, releasing electron, and this electron will be used to reduce oxygen in the water to form hydroxide. So this is the basic electrochemical reaction of corrosion happens in aircraft. And there are many forms of corrosion, like uniform corrosion, but mostly we cannot see uniform corrosion in modern aircraft because modern aircraft are very well protected. Aluminum, starting from aluminum, bare aluminum, and then anodizing to increase the thickness of protective layer, and then added by painting. So many layers is applied to protect aluminum from corrosion. That's why we normally don't see any uniform corrosion. A corrosion that generally we can see, for example, on cars, we can see change color to brown, red, etc. Mostly, the form of corrosion are corrosion in specific area, in a localized area, such as exfoliation corrosion. For example, this one happened in the cockpit. Microbial induced corrosion on fuel tanks, access door, galvanic corrosion on the bushing assembly. Okay, some of the example of aircraft corrosion, and many are in the form of localized corrosion. Nowadays, for example, this Boeing 787 is composed of 80% composite by volume. By weight, Boeing 787 has 50% composite, 20% aluminum, 15% titanium, 10% steel. Somehow, in some place, composite will be connected with aluminum, with titanium, with steel. And when different materials are in contact, it may initiate corrosion process. In the joint, there will be crevice or very small space in between two different materials. This may create crevice corrosion. Two different materials in electrical contact will initiate galvanic corrosion, and there are also possibility of self-corrosion or normal corrosion. So one of the important form of corrosion can happen in modern aircraft is galvanic corrosion because of the use of composite. Okay? More and more, like now Airbus 350 use more than 50% of composite in the structure, and this composite will be connected with metal part, okay? And the connection can be source of galvanic corrosion. Okay? This galvanic corrosion will occur when we have active metals like aluminum, steel, stainless steel, titanium in contact with composite, usually carbon fiber composite. There's electrical connection, and there is electrolyte presence in between, and there is a presence of oxygen too. And this galvanic corrosion will happen on the metal part, but can also include hydrogen cracking in the composite part. So that's why this forward fuselage of Airbus 350 is made of full composite to eliminate the possibility of galvanic corrosion. There are so many factors influencing corrosion, starting from design factors like material selection, selection of surface protection system, drainage, use of sealing to eliminate crevices, use of corrosion inhibitors compound, access to maintenance. There are also operating factors like internal environment, condensation on internal surfaces, spillage of liquids in the cargo compartment, leaks in the toilet or kitchen, clothes or humid insulators in contact with metal surfaces, rainwater. Okay, like in this front door. The front door usually is the only door we use to embark passengers. So when it rains, some rainwater can also enter this door, and maybe it can goes into the crevices and go inside, and then may create corrosion in the long run. There is also external environment like geographical zone near the coast, like Indonesia. So many airport near coast, and the air in the coastal area contain humidity and also chloride from the seawater. Or industrial environment like Surabaya, flight roads, volcanic ash like in Indonesia, aircraft use, salting of runways like in North America, and seaplanes. And also maintaining practice like organic coating, deterioration of corrosion inhibitor, etc. So this is what happened to the forward entry door of 767. After so many years, there is a corrosion happen under this entrance. Airworthiness has also relationship with corrosion. We define airworthiness as the capacity of the aircraft to withstand all design loads according to the fail-safe concept during its service life without serious damage. Uncontrolled corrosion can synergize with mechanical fatigue, resulting in unpredictable crack initiation and propagation. If it is only mechanical fatigue, actually we can predict when or how much crack will propagate, how long it will propagate, and we can calculate is it still safe to operate the airplane or not. But when corrosion also happens, we may not be able to predict the crack propagation. So that's why we need to employ corrosion prevention and control during service, or the corrosion prevention and control program CPCP, which can be realized through a maintenance program that defines the corrosion grade. So there are 3 grades of corrosion for the aircraft. Grade 1, corrosion is encountered, so we knew the corrosion in successive infection intervals. So during the infection interval, we see the corrosion, but it is still within permissible limits. Grade 2, corrosion is encountered in successive infection interval, but exceeding the permissible limits. Grade 3, corrosion is encountered in the first or subsequent infection and is considered urgent airworthiness problem. So it's exceeding the permissible limits and we consider it urgent. This photograph show technician apply inhibitors to parts of aircraft that prone to corrosion. There are so many techniques to control corrosion. Okay, so we can reduce the risk of aircraft corrosion by properly select the materials. So if we choose carbon fiber composite with then we connect it with aluminum, be aware of electrical connection. And then better drainage and strategically placed, so there should be some place to dry up if water enter part of the airplane. Water that enter space between plates or between a tight space in the structure is problematic because, for example, an aircraft just flew from Jakarta and inside a space there is water. And then this aircraft goes to Canada during winter. So the water will turn into ice, and we know that the volume of ice is bigger than water. So there is increase of volume, there is pressure built up, and it can destroy some connection, okay, joint, or initiate cracks. And then how to reduce the risk of aircraft corrosion? Use the latest primer coating, painting, enamels. Use of sealants to eliminate the entry of moisture into structural joints. And then electrical insulation for composite aluminum joints to prevent galvanic corrosion. This is what Boeing applies to their 777. So they take the environmental severity to determine where aircraft should be assembled. So Boeing assembly factory, one is in Seattle and one is in South Carolina now. So these two places has different humidity, etc., and it should be considered. Electrical insulation scheme at the connection between composite and metals like this one. So there should be connection between the composite and the metal part. So in this case, for example, the CFRP, composite carbon fiber reinforced plastic or composite, in connection with rivets, which could be stainless steel or titanium, with aluminum part. So in between, they put fiberglass layer. So fiberglass is non-conductive. So with this, we cut the electrical connection between aluminum and carbon fiber composite. And with this, we prevent galvanic corrosion. And this has been applied to many, to other aircraft that use composite, more and more composite. So that's what we can do to reduce the risk of aircraft corrosion. So by this, I think we can have more time for discussion later on. So by this, I would like to thank you for your attention. I will return the time to moderator. Thank you so much.
Okay, thank you very much, Dr. Hendra. Merci beaucoup.
Dari.
Okay. Thank you once again, Dr. Hendra, for presenting us with the aircraft corrosion. Now we know that the bigger the aircraft, it's mean that the bigger engine is needed in order to give the more power, and also it's been will be the additional in the term of the weight of the aircraft. In order to reduce the weight of the aircraft, that we need to use the material that lighter than the aluminum alloy, but has the same or maybe better strength than the aluminum alloy. And there are many forms of corrosion and many factors that affecting the corrosion to the aircraft. Moreover, there are many ways to reduce the risk of the aircraft corrosion. That's maybe what the conclusion that I can make from your presentation. And I believe there are many questions from the participants. Do you have any question from the participants? Yes? Okay, please keep your questions. Please make a note, and Dr. Hendra, please stay with us, because the Q&A session will be conducted after the third speakers deliver the presentation. So after this we will have yes, Dr.
So
Hendra?
in that case, maybe you can organize all the questions and send to my email, because the third presenter will be, so here will be after midnight, so I might not be able to follow up to the end.
Okay, now is 9:25, and I think on the schedule the break will be 9:35. Is it okay if we have maybe like a 2 or 3 Q&A by MC? Is it okay? Oh, okay, okay. Let's we open maybe 2 or 3 questions from the floor regarding the aircraft corrosion. If you hesitate to deliver the question in English, maybe in Bahasa, okay, Dr. Hendra?
Of course.
Yeah.
If you you can also say it in Sundanese if you wish.
Oke, in Sundanese okay as well. Jadi teman-teman kalau ada pertanyaan terkait aircraft corrosion, mungkin bisa juga disampaikan dalam bahasa bahasa Indonesia atau bahasa Sunda pun oke, kata Dr. Hendra.
Alright.
Silahkan mungkin.
Please, for the participants. Yeah. Okay.
Ya, ada satu di belakang.
Is there any microphone over there?
Oke, silahkan sebutkan nama dan pertanyaannya.
May I introduce myself? My name is Edwan Permana. I'm from aircraft maintenance. I'm a cadet from Polytechnic Penerbangan Surabaya. May I ask about the seaplane? So the landing part of the seaplane is always touched the water when it landed on the sea. So my question is, how to maintain the landing part to avoid such a corrosion? That's my question. Thank you.
Okay, thank you very much, Cadet Permana, for the questions regarding the seaplane, about the floating, how to maintain the floating device of the seaplane. Okay, is there any one more question? No?
One more question, cadets, maybe?
Cadets or maybe from the guests? Lecturer as well? No?
Okay, none.
Okay. One question, Dr. Hendra, about how to maintain the floating device of the seaplane in order to reduce the risk of the corrosion.
Okay. Thank you so much, Cadet Edwan Pramana. I always like when students ask questions. I appreciate your question. So for seaplane, the floating unit always touch seawater, and then when it fly, it will dry up, then touch again, wet again. dry up again. So in general, we see from the beginning, to reduce the risk of corrosion, we start from selecting the most appropriate materials. Corrosion will not happen on non-metals. Okay, so floating unit can be made of fully composite, could be fiberglass composite or carbon fiber composite with less connection with metal spot. So once it is not metal, for sure it will not corrode, but there will be other mechanism of degradation. When it is too expensive to make the floating unit from composite, we can still use metal, like for example aluminum alloys. So protect these aluminum alloys from contact with water by anodizing and then coating with polymer. Okay, that's the first line of defense. And then we add other protection, which is inhibitor, corrosion inhibitor. It's like spraying oil, okay, special oil could be organic, inorganic, that will make water, will repel water. Okay, that's why I think according to the information from Captain Hariri when he was the head of API Banyuwangi, he said they use inhibitor for the floating units like every 25 hours of flight. So it's a lot, but it is requirement from certain regulation. So like that, okay. Proper selection of materials and then proper protection by coating and then by corrosion inhibitor. Those three we can employ to reduce the risk of corrosion on the floating unit. But also remember, it's not floating unit that is prone to corrosion, but also other part that doesn't really necessarily touch the water, but it will be in contact with splashing seawater, also in contact with the humidity or water vapor from the seawater. Okay, even we see it's dry, but actually there are a very thin layer of water on the surface. So yeah, so material selection and then choose the right materials, and then if it is already there, and make sure that the coating still good, no scratch. If we see scratch, repair it immediately, and then use corrosion inhibitor, the spray or other type of corrosion inhibitor. And then always employ regular maintenance check-up for corrosion. So in this part, if Polytechnic Surabaya or API Banyuwangi, for example, or any other program maintenance and aircraft structure, conduct some research in connection with corrosion of aircraft, we can always collaborate for further developing new corrosion inhibitor or new coating to prevent corrosion, and also to prevent sea molecules, okay, sea microbiota that can grow on the floating unit of a seaplane. I think I hope it can respond to your question, Cadet Permana.
Okay, thank you, Dr. Hendra, for the answer of Cadet Permana questions. Okay, if you still has any doubt, and also for the other participant, please feel free to send your question to Dr. Hendra's email The address you can get from the community. And Dr. Hendra,
Excuse me, sir. May I take your time? Is it okay if one more question because there is a question given online?
Okay, please.
So, yeah, this is
One more question, Dr. Hendra, please.
all right. So this is given by Robbie. He asked about what are the factors affecting corrosion in the tropics. Is it clear?
Yeah.
Okay, please, Dr. Hendra.
Okay. We go back to. Yeah. So factor affecting corrosion. Factor influencing corrosion or factor that aggravating corrosion. In tropic, especially the coastal zone, okay, the marine environment or the seawater. Seawater is very corrosive. It can attack stainless steel. It can attack aluminum alloys. It can attack titanium easily. So yes, this is very special in the tropic, especially Indonesia. So many airport near the sea. Also volcanic ash, but this may also affect the engine. Seaplane. So what can we do? Make sure that good maintenance, and this CPCP program should really very disciplined in employing this CPCP program. Okay. Check for sign of corrosion, especially corrosion grade 2 or grade 3. So that's the specialty of tropical regions. It's hot, humid. So many factors the most important factor that influence corrosion in the tropic.
All right.
All right, I think that's enough because we ran out of time. Thank you once again, Dr. Hendra, for the very good presentation. Je vous remercie for votre belle présentation. And
Pleasure, sure.
à bientôt, au revoir.
À bientôt.
Okay, we give a big applause for Dr. Hendra. And for the participants, please stay with us because we'll still continue our next speaker. But before that, we will have a short break. So for the session, I'll give back to our lovely MC, please.
All right, thank you. Again, my name is Firda, sir, if you forget my name. All right, so ladies and gentlemen, you may have a first coffee break, but during the coffee break, we will have a very special performance, which is playing angklung together. So you may now get each one of you has angklung, right? Okay, so we will play together, and this will be led by Surabaya Angklung Percussion. All right. Okay, for Bapak Jaya, time is yours.
Cek, bismillahirrahmanirrahim. Okay, good afternoon, ohayo gozaimasu, watashi wa Jaya desu ka. Ini adalah pengetahuan pelajaran bahasa Jepang pertama saya ketika saya ada di Bali waktu itu. And I'm really dreaming that someday I have wife from Japan, because I admire the girl from Japan. They're beautiful, they're sexy, and they're royal.
Japanese girl.
Yes.
Okay.
About culture, Japan's and Indonesia is very have a similar culture. what is the similar things is from bamboo, you know. Bamboo in Japan, they made bamboo for everything in their daily life, yeah. Similar with Indonesian, you know. But first of all, from Indonesia, our culture, bamboo, we can play it like what you did today. Asik kan? Ya, playing angklung, karena aku belum memberitahukan kepada Bapak Ibu sekalian, kepada para taruna taruninya, ya kan sudah dimainkan kan angklungnya asik ya. Nah, please try.
Shake, shake, shake your bamboo, your angklung.
Okay, that's nice. Amazing. Okay. Angklung, there's a number. Every each angklung that you play, there's a number in front of the tube. There's a 1, 2, 3, 4, 5, 6, 7 until high 1. There's a 1, there's a dot at the top. That's right. Okay. To make it easy, I will give you the code. If I give you this Senhain, please play number 1, angklung number 1. Okay. Number 1, number 2. Number 3, number 4, number 5, 6, 7,
The last one.
okay, the last note.
Yeah. over there.
High do. Do
High
tinggi.
Ya, high
Do
do.
tinggi.
Well,
Yeah.
do tinggi teman-teman. With one dots at the top.
Yes. Okay, let's do it again. 1, 2, 3, 4, 5, 6, 7. I. We call it I, yeah? E. So make it easier.
Okay.
Okay?
You got the point. Okay.
Okay. One more time. Seven. I. Satu dan nada I sama. Satu dan nada I sama. Ya. 7. 7. Okay, as long as my hand still in number 1, in number 2, and number 3, so you might shake the angklung, don't stop it. Okay. Kita akan memainkan lagu apa tadi? Lagu apa nih? Ini yang saya mainkan.
Unpredictable, Pak.
Lagunya Falling in Love with You.
Oh.
Ya, oke.
Can't stop falling in love with you. Right.
Keyboard bisa main nggak keyboard? Nada C, diiringi nada C. Oke, pakai string aja, string. Oke, kita mainnya semangat ya, semangat ya. Oke, dari nomor 1. C. Tiga. Oke, tepuk tangan dulu dong. Kalau di Bandung mainnya berbeda dengan di Surabaya. Di Surabaya kita juga punya pelatih angklungnya, kita juga punya pelestari angklungnya. Oke, kita lanjutin lagunya ya. Bahasa Inggrisnya apa Mbak ya? Kita lanjutkan lagunya.
We continue.
Bukan, bahasa Jepangnya.
Oh, I'm so sorry, I know nothing about Japanese.
Okay, let's continue. 1, 7, 7. Enam. Tepuk tangan dong, give applause.
Give a big round of applause. Can't help falling in love with you.
Amazing. Itu adalah lagunya Falling in Love with You. Kalau mau lagunya yang agak sedikit goyang mau nggak? Cok dibanding kayak gitu. Yang lagi viral. Kita coba ya bareng-bareng ya. Enak gak enak urusan buri gitu ya. Ya, oke? Nada 1. Oke.
Yeay. Aja dibandingke ya itu tadi Pak.
Ojo dibandingke.
Walaupun saya agak bingung kalau mau nyanyi tadi tuh.
Perbedaannya ini kan it's called angklung interaktif. Angklung interaktif ini kalau misalkan dimasukkan ke temponya lagu dia nggak bisa langsung klik karena angklung interaktif dia lebih lambat, jauh lebih lambat gitu. Oke, that's it our meeting today. Saya harap Bapak Ibu sekalian saudara-saudari taruna-taruni sebangsa dan setanah air bisa berbahagia. Sebuah budaya untuk kita semua. Salam, terima kasih, sampai jumpa lagi.
Alright, thank you very much. Please give a round of applause once again for Surabaya Angklung Percussion. Are you all happy to play angklung together? Happy? Alhamdulillahirabbil alamin. So it will not be boring because maybe you will think that seminar is always about thinking and thinking about one serious thingy to one another. But then now we have a special performance from Surabaya Angklung Percussion and we are all happy because of him leading us to play it together. Alright, so next we still have two keynote speakers to continue our today's event. I will invite once again to Mr. Bahrawi, our moderator, to handle the seminar again because we still have two keynote speakers that will share the knowledge, the insights to all of us today in this place. So please welcome and please give a round of applause again for our moderator, Mr. Ahmad Bahrawi.
Okay, thank you very much, Ms. Firda, for the time again to moderate the second session of our today's seminar. I hope the session was refresh you again. Maybe, is there anyone can have a time to get their coffee or maybe tea? I don't think so because you are very excited to play the angklung, right? Yeah. Okay, our second session will be delivered by Professor Taufik. Is Professor Taufik already with us? Okay. Good morning from Indonesia, Professor Taufik, or good night in United States. Okay, we cannot hear you yet, sir. Okay.
Oh. Can you hear me?
Oh yeah, we can hear you loud and clear now.
Hi.
Okay, how are you
good
today,
morning.
Professor?
I'm good, Alhamdulillah, thank you. Hope
Alhamdulillah.
all is well with you as well.
Okay, thank you very much for giving us your time and share your knowledge with us on this seminar. Okay, before I give the time to Professor Taufik to deliver us about the hybrid alternating current direct current house paving a pathway for future sustainable homes, I would like to introduce Professor Taufik. Professor Taufik is the Professor of Electrical Engineering, Cal Poly State University, California, United States of America. He holds a Bachelor of Science, Electrical Engineering and minor in Computer Science from Northern Arizona University, Master of Science, Electrical Engineering and Computer Science from University of Illinois, Chicago, and Doctor of Engineering, Electrical Engineering from Cleveland State University. He has a vast experience and also research in electrical, and he got some award and recognition. One of them is from the is the Outstanding Achievement Award in recognition and appreciation of the research contribution to the field of power electronics, present in the International Conference on Computational Science and Computational Intelligence, Las Vegas, in December 2019. And also, he has some project and master thesis and supervised a total of 211 senior design project and supervised 90 master thesis. This was very great experience. So. Okay, without further ado, let me give applause to Professor Taufik.
All right. Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
First of all, I would like to say thank you for inviting me to this conference. Gratitude to all the committee members and Paul Tech Bank, I believe is the name, for giving me the opportunity to share my experience, a little that I know about electrical systems that I will be presenting today. Also, just like Kang Hendra, I would also like to extend my greetings to Kang Hendra himself, as well as Mas Aziz from Japan. Great to see you again in another conference. Hope you all are all well, doing well. Also, I would like to say hi to everybody. I know I've not had the chance to visit your campus, but hopefully someday I will. Inshallah, if everything goes well, my plan is to visit Indonesia next year, and hopefully we'll have the time to schedule a meeting on your campus, and I'll be more than happy to, discuss any potential collaboration that we can do between Cal Poly and other campuses, including your campus. All right, so my presentation today is not directly related to. Let me share my screen first. If you can do that. Hang on. Let's see this first. All right, let's see. Can you see my presentation?
Yes, we can see it.
All right, thank you. Okay, so my presentation is not directly related to airplanes or any aspects of the aircraft design. However, when I'm doing this presentation, I would like you to think of how we can still relate this discussion to airplanes, right? Specifically on the electrical system of the airplanes. I do not specifically research on airplane electrical system. However, my focus of the research has been mainly on DC electrical systems, which I believe is going to be the future electrical systems. And so related to that, since 2010, I've started this research topic on DC house project, and since then it grew into what I call hybrid AC-DC house for future home. So that's the title of my presentation today: hybrid AC-DC house, paving a pathway for future sustainable homes. Again, please, when I go through the presentation, think of how this topic can relate to electrical system in airplanes. Just quickly about Cal Poly. It is a school that was founded in 1901. Started as a polytechnic school, but it was converted into a university back in 1972. And so as of today, I don't think there is any more polytechnic college in the US. All of them have been converted to university, including Cal Poly. But the name still remains because we've been known to be a Cal Poly, so we don't want to change the name. So it stays with the Cal Poly flavor. It's a non-PhD granting school with about 22,000 students and about almost 1,500 faculty. Yeah, it's in terms of the campus itself, it's actually the second largest in California after UC Berkeley. Very big land. And here's the location of Cal Poly. If you look at the US map, we are on the west coast of the US, specifically in California, state of California, as you can see from this picture. And we are located in the middle of the state. So California is a very long state, right, north to south. Takes about, I would say, 8 to 10 hours of driving between the south part to the north part. And our campus is right in the middle. So our location is called Central Coast area. And as you can see, it is in the middle of two big industrial areas. One is Silicon Valley, and to the south of us is LA as well as San Diego area. So, but it is a tourist place. It is away from the hub of the big towns or big cities. And here's a picture of the campus. As you can see, it's surrounded by rolling hills, beautiful campus, in my opinion. It reminds me of Indonesia as well, with the mountains. And the beach or the ocean is not too far, which is about 15-minute drive from the school. And so with that, I would like to extend invitation to any of you if you'd like to visit our campus. We have had some visitors from Indonesia, as well as from other countries. They're doing visiting as a visiting scholars, as well as just visiting to explore collaborations. As you can see, this was before pandemic hits. This was the last group before everything was shut down due to pandemic. So we had a group of faculty members from Icateas, Institute of Technology, School of November, I believe that's the name. Yeah, so feel free to contact me if you're interested in visiting us in the future. All right, so that's enough for brief introduction to the school. As part of the presentation, here's the outline of what I'll be presenting tonight, or today, so this morning in your time. First, I'll talk about future sustainable net zero energy homes. I'll talk about problems with AC and the need to complement with DC, propose solution with hybrid AC-DC, challenges and opportunities, as well as what we can do for the near future. And then I'll close it down with summary. Now, before I start, I've included these two pictures because these two relates to aircraft. Right? I've had the opportunity to actually help design these power supplies for this fighter plane right here. I don't know if you are familiar with this fighter jet. It's called F-35, the latest and greatest of the fighter jet plane made by the US. And I've designed 3 power supplies for these airplanes some time ago. So anytime I see these airplanes flying by, it reminds me of the time when I actually designed the power supplies for these airplanes. And then the bottom one right here, that's a micro turbine, right, which is a generator that is being used in airplanes. And this was back in 2005, 2006, when I worked for a company that would convert these micro turbines into a generator. So going from 96,000 RPM into a 60 hertz output. And so that was a challenge, very challenging problem. And I was involved with the engineering team that was responsible for designing the controller for this micro turbine, to go from, again, 96,000 RPM into 60 hertz output power. So I thought I would mention that because these two pictures relate to aircrafts. All right. Now, back to my presentation. When it comes to future homes, what we are thinking of, or what many people are thinking of, is what we call NZEH, which stands for Net Zero Energy Homes. And what is NZEH? Well, NZEH is defined to be a grid-tied, energy-efficient house that produces as much renewable energy as they can over the course of a year, resulting in a net zero energy bill and a carbon-free home. And in order to achieve this type of house or home, we have to be able to somehow assemble, different technologies, right? Not just electrical system, but also materials, um, 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 computers, digital, you name it, right? So many technologies assemble into this future house. Now, the net zero energy homes mostly is running off solar panels for now, but in the future it'll have more than just solar panels. And in addition to the renewable energy that is being used for the house, this NZH in the future will also be a smart house. A smart house or a smart home will incorporate some sensors, right? And sensors to do many things in the house, right? Watching or monitoring some activities in the house or managing energy in the house, what have you. And so these sensors are typically running off DC, right? Just like solar panels putting out DC, these sensors that are being used will also be running off DC. Now, based on what we have now, it will be challenging if you were to stick with the AC legacy system, because that's what we have right now, right? AC. Your house, my house, right now is running mostly AC system, but yet in the future, the vision is that we're going to be using more and more DC. So by sticking with AC, I think it will make it more challenging for us to transition from traditional house to future house. Now, what is the problem? What are the problems with AC? Many. First of all, if let's say you have a DC load, again, you can think of it in the airplane as well, right? You plug in your smartphones into this wall plug, and this wall plug is outputting AC, right? And your smartphone is actually running off DC from the battery inside, right? So in the process, you have to convert from AC to DC. And when you are doing so, right, you're going to be experiencing about 17 to 35% loss. Right? That's the type of loss that you'll be getting if you convert AC to DC. Right? That's quite a significant loss, as you can see. Right? And another problem with AC is that AC is harder to control than DC. An example would be that in DC, if you're running DC electricity, there is only one type of DC power, right, which is called watts, and that would be it. That would be the end of it. However, if you're talking about AC, if you are using AC, then you have to deal with multiple type of power, not just one, but also several, or a few number of powers. For example, in AC system, we have instantaneous power, average power, the active power, complex power, as well as apparent power. So it's more than just one. So having more than just one type of power makes it more complicated to control AC electricity. Compare that to just one type of DC. Right? And then AC system or AC electricity would most likely require compensation, right? Because of the fact that loads would be inductive, and then you have to somehow compensate for the reactive of the load, and so on and so forth. Unlike DC, in DC there is no reactive power, right? So there is no need for us to do reactive compensation for DC electricity. Now, hopefully I convinced you the problems with AC, right? Mainly efficiency and harder to control. And the next one would be based on what we've seen so far. Hopefully now we see the needs to complement AC, right, with DC. Now, why? Well, there are a number of reasons. Number one, the increasing number of DC loads, right? Just look at your house. Nowadays, our house is using LEDs, right? LED light bulbs. Compare that to 10 years ago, where LED light bulbs are very scarce, right? So now we have more and more LED light bulbs, and LED light bulbs, as you know, operates on DC. Same thing with smartphones, right? Smartphone, if you look at it globally, by 2021, there's about 2 billion smartphones around the world, right? 2 billion. Now, let's do some simple math, right? If every single smartphone that we charge requires 5 volts DC, right? And when you're charging it, let's say it requires 1 amp to charge it, and then it takes about 1 hour to charge. then you multiply that, these numbers by 2 billions, that would give you easily, as you can see, gigawatt hours of energy. As you can see, a single smartphone doesn't mean much, but when you accumulate 2 billion smartphones globally, you see the number becomes more than just significant, right? It's humongous, as you can see. Right? So that's a lot of energy being processed through DC. So it makes sense for us to be able to somehow complement AC with DC. Another reason is this upcoming technology, which is already here, but it's still going to grow. It's called USB-C. Right nowadays, you have devices, laptops, smartphones, tablets that have USB-C plugs instead of the USB 3.0 or 2.0. Right now, you can see that USB-C has become the predominant connector for portable electronics, and there is a reason why. Right, from electrical point of view, power point of view, the targeted power for USB Type-C is actually 100 watts. Compare that with USB 3.0, which is about 15 to 20 watts. So now with USB-C, eventually we're able to pull out about 100 watts of DC power. Now that's not the end of it, right? Nowadays we have about maybe approximately 60 watts that we can get from USB-C. However, there is a new standard for USB-C that would come out pretty soon. And check this out. It's going to provide or targeted output of 250 watts. Now, instead of 150 watts, it's going to be 250 watts. Can you imagine what kind of DC loads you can power with 250 watts in your house? A lot, right? It's not just small devices anymore, but now you can actually start powering, for example, refrigerator, right? Small refrigerator with a USB-C in the future, of course. Not yet here, but in the future. So, but the main point is, right? You can see that the technology that would facilitate, DC power is getting there. Right? So let's take advantage of it. And I ran very quick statistics some time ago. Year 2018, that was 4 years ago. And I compared the mixture of AC and DC loads in a typical residential house in the US. In 2000, DC loads makes up about 20% of the entire load in the house. But then fast forward to 2018, you can see that the mix of AC and DC becomes different now, right? Now DC is changing. Now DC is growing up to about 30%. Right? So now it's an increase of 10% in 18 years. Now, I would suggest that the mix or the percentage of DC loads in developing countries such as Indonesia, it would be bigger. The reason being, in the US, the AC loads that we have in the house pretty big. Such as air conditioning, we have a big air conditioning, refrigerator, and then a big washing machine and dryers. And then the DC loads, again, it's going to be a higher percentage then because of that, right? If let's say the washing machine is smaller, the fridge is smaller. So that's what I would suggest is going to happen in Indonesia. It's going to be a larger percentage of DC loads. And also in terms of the source itself, people in the US, for example, has becoming more aware of renewable energy, and they start putting solar panels on the rooftop. And once they do, then basically they have DC source on their fingertip. So once you have a DC source on their house, and if the loads are DC, then it would make sense to me if we convert that DC from the solar panel straight to the DC of your loads, rather than doing this, right? This is what we are doing now on the bottom diagram right here. If you have a solar panel nowadays, you have to convert that DC into AC, and then from AC into DC, and then from DC to DC. As you can see, we have multiple stages of conversion converter, right? And of course, this is not good because then in the process, every single process will introduce some losses, right? Compared to just one loss on the direct connection on DC to DC. And so what I'm suggesting is that hopefully in the future, we go with the first approach. It'll be more efficient. And I won't go through this in details, but future house will also have a lot of smart home devices, right, such as cameras, alarm systems, you name it, all kinds of smart devices. And those are running DC. And not to forget about this additional equipment that more and more people are using these days in their house. That would be energy storage. Right? Probably you've heard about Tesla Powerwall, right? So batteries that would be sitting in a garage, right? That would be coupled to these solar panels. So during daytime, when the solar panels receive more energy than the house needs, then the extra energy will be stored in these batteries, right? And at night, when the solar panel is off, we can make use of the energy from the batteries into the house. And as you know, batteries are DC, not AC. So that's another reason why I believe DC becomes more important. All right, so this next slide shows you the basic diagram of hybrid AC-DC. Right? So what is hybrid AC-DC? Again, you can change the house into airplanes or aircraft. Right? You can again, it's not really that different between a house and an aircraft. Right? Inside, in terms of electrical system, you could definitely somehow rethink of how we can network the electrical system inside an aircraft, just like we are doing with a house. So what it is this. If you have a hybrid AC-DC, right? So you have two sources from PLN. If it's the house, it's from the generator, AC, and then from the solar panels, which is DC. And then in the house, you have two different types of loads, AC loads and DC loads. AC load could be something like heaters, air conditioning, right? Washing machine, and then DC loads could be the lightings, chargers, phone chargers, and so on and so forth. And so there is a direct path, as you can see, from AC source to AC loads. That's the direct path right there. And there is a DC direct path from the solar panels to the DC loads, as you can see from here. However, in order to increase or improve reliability, we also provide crisscrossing of the path from AC to DC and from DC to AC, as you can see, right? This way, if for whatever reason, the utilities or PLN is out, let's say you have a blackout, then the AC load will still be powered by the DC path right here through inverter. And as you can see, for the DC path, you have more stuff inside this box. You have the MISO, which stands for multiple input, single output, just like the Japanese soup, right? MISO, except this MISO again stands for multiple input, single output, meaning this converter has multiple inputs right there and only single output, right? And here's the picture of a hybrid AC-DC system that we've constructed at Cal Poly, my campus, right there. We have a shed, and inside the shed, we've put together the hybrid AC-DC system using solar panels and then the AC from the utility side, as well as the battery right there, right? All right, so then challenges of putting hybrid AC-DC. A lot of challenges. However, challenges, I keep saying to everybody that challenges present opportunities for new technological developments, which further on will bring in innovations. So it's actually good to have challenges, right? And what kind of challenges do we have for hybrid AC-DC? Quite a few. Right? Number one is we have limited DC sources, and so we need to somehow come up with creative ideas to do this so that we can maximize the use of renewable energy source. And then we also have the challenge in adopting renewable energy. I'll elaborate this a bit more later. And then the MISO converter, remember the MISO, multiple input, single output, that also needs further development and commercialization. DC bus and loads are not standardized. I'll elaborate later as well. And DC is more difficult to protect. And finally, there are strict regulations for backfeeding power. And lastly, it'd be nice if we could somehow be able to manage all of these different systems in our house as well as in any electrical system. So here's the first challenge, right? In the US, we call this NIMBY. Right? NIMBY stands for not in my backyard, right? I mean, imagine if you have a house and you want to use renewable energy, right? Do you want a big wind turbine to spin in the backyard like this? I would say probably not, right? Most likely not, because that's going to be just ugly and noisy, and it's taking up a lot of space, right? So again, not in my backyard. You know, your backyard is fine, but not mine, right? So how can we then adopt, renewable energy technologies into our house or aircraft or ships, whatever it is, right? So come up with some creative ideas that could actually make it more adaptable. For example, rather than having blades for the wind turbine, why not get rid of the blades, right? Such as this one right here. This has already been launched. This product called Rich Blade, where the wind generator is actually inside the rooftop of a house. This structure right there that you see, right, besides the solar panel, is actually there's generators inside. So wind will flow into this opening and will turn or spin the generator inside. Pretty clever, right? And then we have this wall, wind power wall. So it has a wall that has some kind of a spinning structure, right? We can call it blades if you will, but it's more aesthetic, right, than big blades like that, right? So again, these are just a couple of creative ideas that have been, proposed or been established or been constructed out there that would relate to how we can adopt wind generation onto our house. And sky's the limit, as you can see from many of these pictures. I won't go through this in details, but at Cal Poly, for example, we've constructed what we call play park generator. Right? So from the swing, kids can play, and at the same time we can charge the battery, and we can charge our smartphone by doing so. Right? A seesaw game like this, right? You can also create some energy that could then be charging a battery, and as well as merry-go-round. All of these are part of play park. Right? Imagine if kids can play with this, and then at the same time we can somehow store the energy into a battery. That'd be nice. All right. Another challenge would be unifying EMS. Right? EMS stands for Energy Management System. If I have different aspects or components in the electrical systems, how can we manage or coordinate all of these components? It's not an easy task to do. It's easier said than done, right? You have a source right here, you have another source right there, you have loads right here and loads right there, and you have all of these converters. How can you make every single component talk to each other? Right? So that's a challenge that I have not actually addressed. So feel free to contribute on this aspect if you're interested. And on the MISO side, it is also a challenging problem. So the purpose of MISO is to be able to combine energy from multiple sources into one single DC bus. So I started looking into MISO converter from 2014, and then alhamdulillah in 2018 we found the key to solving that problem, and we're able to patent the technology. So that's the US patent that we get, and there's the MISO converter that we invented at Cal Poly, right? What is another challenge? Well, DC, unlike AC, is not very hard to, or it's not standardized, I should say, right? In Indonesia, for example, if you look at the wall socket, every wall socket in Indonesia is standardized to about 220 volt AC. Same thing in the US, it's about 110, 115. So you can just buy any AC appliances and then you can just plug it in and you won't have to worry about the voltage because they're all standardized. DC is different, right? DC, there's no standard, right? So, but however, DC loads are like all over the place. Some DC loads would require 12 volts, Some other ones would require 24 volts. Some other ones would require 48 volts. So then it'll be what do you call it? It will not be wise if you design a system that has multiple wall plugs, right? Imagine the difficulties if you provide multiple wall plugs, one for 12 volts, one for 24 volts, another one for 48. That would not be wise. So then the idea here is that why not have a smart DC wall plug, right? So you have a wall plug like this, but it's for DC, and behind this wall plug there is a brain that would be able to adjust, right, what kind of voltage the load would require. So if you plug in a 5-volt load, then this wall plug will be smart enough to figure out, hey, this load requires 5 volts. And that's the idea behind this smart wall plug. So if you're interested in doing this, let me know as well. Another big challenge in DC is that DC is very hard to protect, right? Unlike AC, AC goes from, AC has zero crossing, so the AC signal, as you know, follows sine wave, and sine wave goes through zero, right? DC is always high, right? If it's always high, then how do you interrupt the current? It's going to be hard to interrupt the current if there is a fault in the system. So it's going to be more challenging to protect DC. Same thing with arcing, not arcing, DC arc fault. Between two wires, if you have AC system, if the two wires are worn out, right, or in Indonesia maybe there's some mouse chewing on the wires, then now those two wires become exposed, then you can have arc fault current jumping from one wire to another wire. And in AC, it's easy to detect that. But in DC, we found it's not so, right? So in DC, if you have an arc fault current, you cannot use time domain solution. You have to use frequency domain solution. So that's another challenge. I mean, this is the arc fault interrupter that we developed at Cal Poly right there. So it's able to detect arc fault current between two DC wires. All right, opportunities. What can we go from? Where can we go from here? A lot of directions that you can go from. DC system, hybrid AC/DC. Again, this could be implemented in aircraft. One would be rural electrification, right? So if you have a village that has cluster of houses such as this will be perfect for having, DC house, hybrid AC/DC, right? Here you can actually network all of these houses into one single DC bus, so they can exchange energy. So if one house is blacking out, the other one can supply the power to that house. So that's called network. I won't go through this one, but you can see briefly the two different approaches of traditional way of providing power in rural areas using micro hydro or solar farms or wind farm, as opposed to using the technology that I'm offering, which is the DC house network, hybrid AC/DC house network. With this architecture right here, you can improve reliability compared to the traditional approach. That's for another presentation maybe. What other opportunities? Now we can think about, since remember I said earlier about USB-C being able to support 250 watts. Now is our chance to be able to design and produce more DC loads, such as DC refrigerator, DC TV, DC freezer, DC air conditioning, and so on and so forth. All right, I'm almost done. This picture shows you the several DC house prototypes that I've collaborated with other universities. This is the DC house at Cal Poly. There's a DC house prototype in Pajajaran University, and this one is in the Philippines. I was invited there for 1 month to actually help them build and construct the DC house on their campus. Beautiful bamboo house, traditional house there in the Philippines. And here's the picture of actual DC house system installed in one of the Regency office in Jatinangor, and it's still running as of today. So we're combining small wind turbine with small solar panels. All right. This picture shows you how this is relevant to aircraft, right? This picture I just included here to emphasize that yes, I'm presenting electrical system of a house, but the same idea could be implemented in an aircraft, right? This is an electrical system of an aircraft. You can see we have still problems with rectifiers, a lot of rectifiers, as you can see. These are sources of losses. So if you can somehow shift the mixture of AC and DC, right, to be more DC, then we'll have less and less of these rectifiers. So think of it that way. Okay? That would be the challenge. All right, as a summary, let's collaborate on hybridizing electrical systems. I would encourage us to continue the discussion, continue the connection, partnership between university abroad, outside of Indonesia, to all of the university in Indonesia to do all of these different partnership. And for me, my interest is in electrical systems. So if you are interested in this aspect of the design, then let me know. There is a need to explore DC to complement the conventional AC system. AC is not going away, so the best is to complement with DC. Promote the use of renewable energy, maximize system efficiency when DC loads are continually growing, and that would eventually help achieve the net zero energy houses. DC has technical challenges, but then again, it presents opportunities for new solutions, and hopefully further down, it will also bring up innovations. Hybrid AC-DC house improves access to electricity in rural areas. That's another bonus point, if you will. And then hybrid AC-DC house, to me, is the future house. So therefore, we need to move fast if we are interested in this, and we could be the leader in this field. If you're interested in doing this, if we work hard on this, it's a lot to explore. We can definitely be the leader in the future house technology. So with that, these are the references I've used for this presentation. And if you have any questions, you could email me, or you can go to this website for further info on DC House. And with that, thank you for your attention. And hopefully you learned something from this presentation. Thank you. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Taufik, for the presentation. Do you have a time to have a Q&A after the third speaker, or?
Yeah, just like Kang Hendra, I think it's going to be better if we do it now because it's getting late here in the US.
Oh, okay. So is it okay if I ask maybe 5 minutes of your time so we have a Q&A, and after that you can leave the system, okay? Is it okay?
Yeah.
Mbak Firda?
Yes, sounds good. Appreciate it, yeah.
Okay.
Right away.
Please, I open maybe 2 questions from the floor. If you have something to ask to Professor Taufik, since I will not conclude the presentation because Prof. Taufik already summarized the presentation, so directly to the Q&A session. 2 questions from the floor here, or maybe from the participant on the online. Is there any question about the hybridizing the AC-DC homes?
All right, ladies and gentlemen, is there any question for our second keynote speaker?
No? Okay, I think the presentation already clear, but if you still have any doubt or maybe some question to ask Prof. Taufik, please feel free to send email to Prof. Taufik. And once again, Prof. Taufik, thank you very much for the precious time that you give to us. Even though it's midnight in US, you still give us the very useful knowledge for us. Now we aware that our home appliances is more and more DC than AC. So we need to consider that maybe we can have like innovation from this Poltek Bank Surabaya to provide maybe more sources on DC. So Prof. Taufik, once again, thank you very much. We give applause to Prof. Taufik for the very great presentation. Thank you and have a good night, Prof. Taufik. Assalamualaikum.
Waalaikumsalam warahmatullahi.
All right.
We continue to the third speaker?
Yes, we can continue to the
Okay.
next speaker.
Okay, thank you very much, ladies and gentlemen, for still be here. Now our last speakers is Dr. Engineering Muhammad Aziz. So please welcome Dr. Engineer Muhammad Aziz. Okay, we give a big applause. Ohayo gozaimasu. Genki desu ka? Hai, genki desu. Ya, itu aja yang saya bisa. Before I give the time to Dr. Engineer Muhammad Aziz to deliver the presentation, I would like to read the CV of Dr. Engineer Muhammad Aziz. Dr. Aziz is currently an associate professor at Institute of Industrial Science, the University of Tokyo, Japan. He received Bachelor Engineering, Master Engineering, and Doctor Engineering degrees from Kyushu University, Japan, respectively in the field of mechanical engineering. He was working previously as the associate professor since 2015 until 2019 and assistant professor 2011 until 2015 at Tokyo Institute of Technology, researcher at Institute of Industrial Science, the University of Tokyo, 2009 until 2011, mechanical designer at Seiko Epson Corp, 2008 until 2009, and lecturer at Risumiken Asia Pacific University, 2007 until 2008. His general research area are advanced energy system. His research interest includes power generation, energy management system, renewable energy utilization, process modeling, smart grid, electric vehicle battery, and many more. He received several awards, including Young Researchers Award from Asian Pacific Confederation of Chemical Engineering Congress in 2012, Outstanding Paper Award from Journal of Chemical Engineering of Japan 2013, Japan Institute of Energy Award for Encouragement from Japan Institute of Energy 2016. He owns and manages some national and international research projects, including Japan Science and Technology, Japan International Cooperation Agency or JICA, Japan Society for the Promotion of Science, New Energy and Industrial and Technology Development, New Energy Promotion Council, and others collaborative research with industries and universities. So, ladies and gentlemen, please we give a big applause once again to Dr. Aziz.
Okay, thank you very much for the moderators. Assalamualaikum warahmatullahi wabarakatuh. Very good morning and hopefully very good also for all of us. And just let me to introduce myself. I'm Aziz from Tokyo University. And previously also I think I just would like to correct that I now belong to Tokyo University, not Tokyo Institute of Technology anymore. So I just would like to correct that very little things. So it is my great pleasures. I really appreciate to be invited today. And also I think hopefully that my talk today will be quite fruitful for all of us. Not only for my talk, but I think hopefully that we can also continue for having any kind of more collaborative and also more fruitful collaboration in the future. And as also moderator mentioned previously that because basically my background is mechanical engineering. And now we are conducting research related to any kind of energy systems. And for today, I just would like to show any kind of strong correlations between the energy and also transportations, because as we understand that in the futures, things we have any kind of great shift, great transformations also in our transportation systems, because in energy system there will be and also great energy transitions in the future. So okay, next please, because I can operate from here. So this is our laboratory in our Tokyo University. So we call it as as my name, because usually we belong to, when we can set up any kind of laboratory, means that we have the names of our own over there. So we are focusing on the energy and also process integrations engineering, and now currently also we have about 12 students, and also researchers, 3 researchers, and also about 8 other students. So in total we have about 20 people in our laboratory, and in case that you have any interest to work with us, and also to maybe to have any kind of collaboration with us for being any kind of visitings or any kind of I don't know, it's like collaborative internship or etc. We are really welcoming for that. And so next please. Oh, okay. As the backgrounds of my talk today, I think this is quite general backgrounds for all of us. And now we have 2 different paradigms for the Industry 4.0 and the Society 5.0. So both of them are basically quite similar, but unfortunately both of them also have a quite significant difference. Both of them coming from Germany and also Japan respectively for Industry 4.0, because yeah, it basically rooted from German's ideas, but for Society 5.0 it is basically rooted from Japanese. So why in here we are talking about Society 5.0 more details compared to Industry 4.0, because we are not only considering about the technological transformations, but also we need also to emphasize the characteristic, the cultural characteristics as the backgrounds of our transformations. So in Society 5.0 we are talking about the civilizations, rather not, and it is not, yeah, we are talking also about the technology, but how far we can change our civilizations. So we have 5 different civilizations until today, and now we call it as the ultra smart society, and usually it is called the Society 5.0. And okay, next one please. And what is really happens in the Society 5.0? We are talking about the change, not only the change, but also the shift, how far our cultures, our characteristics also can follow, can be any kind of great investment for the change in technology or etc. So in the Society 5.0, what we are emphasizing for is that we are emphasizing on any kind of transformation, maybe any kind of physical transformations, but also how far we can optimize, integrate also our imagination's capability, and finally also create any kind of creativity. So we have any kind of imaginations to picture or to figure out what we would like to have in the future. And also we need also creativity to devise that we have figured out firstly. So in this case, digital transformation or any kind of transformations, digital, green transformation, or maybe any kind of transport transformations or etc. Basically it is not the aims, it is not final goals over us, but it is only the tools. So our goal mainly is on this one, value creation for all of us. So however, we are not only stopping on the problem solving, but also for the value creation for all of our lives in the future. And there will be any kind of strong correlations between the Society 5.0 and also Sustainable Development Goals set by United Nations. Next, please. And this is the features of the Society 5.0. As we can see over here, there are some different backgrounds for all of us. And I think in terms of Asian countries, I believe that Society 5.0 will be much more compared to Industry 4.0 in this case. So we have facing several problems, including Japanese problems also. I think this is quite similar also with Indonesian problems, because we are also archipelagic countries. We have also different cultures. So in Society 5.0, as I mentioned previously, we are talking about the diversity. We are talking about also about decentralizations. So any kind of shift or transformation is not only focused or it's not only located or positions in any kind of centralized or big city, something like that, but we need also to distribute it equally. So there will be any kind of decentralizations, and also how far we can improve the resilience. The resilience not only in terms of the physical resilience, but also in our non-physical resilience. That's very important. And finally, also we are talking about the sustainability of etc. Next, please. Okay. And as I mentioned also, digital transformations is not the main goal. Yeah, we have any kind of transformations, but now currently we are focusing on digital transformations as the main cause for the technological change. But we need also to develop any kind of elemental technologies because it is the core of the change itself. And as I mentioned previously, that DX or digital transformation itself is a tool anymore. It is not the final goals that we would like to achieve. So we have any kind of, I put the gears over here, is that digital transformations, I think is that this is a tool. And what we are targeting for is that we are creating any kind of culture. How far we can emphasize, how far we can strengthen our culture and also finally also our capacity. So the main target is the value creations. The value creation will be very strongly correlated with any kind of capacity building for all of us, personally and also for the communal. Next, please. When we are talking about the energy, I think there will be any kind of strong correlations between the energy and also sustainability or etc. And when we integrate between the energy and also sustainability, I think we have three different pillars. The first pillar is correlated with energy security, and the second aspect is correlated with energy equity, and finally also correlated with environmental sustainability. When we are talking about the energy security, unfortunately, in conventional definitions of the security or energy security in this case, usually we focus more on any kind of capacity or capability to fulfill the demands of the energy. Yes, that's true, but unfortunately, it cannot cover all the definitions that we need today. So what we need, the definitions, we need to renew the definitions of AI is that it covers both quantitative and also qualitative aspects. For the quantity aspects means that yes, as the conventional definitions mentions, that we need our capability to cover the demands for the energy. But in terms of the quality aspect means that at the same time, simultaneously, we need to cover high quality of the energy. Because what? Because basically the energy must be provided and also must be consumed and also transmitted and distributed in real-time manner, especially when we are talking about the electricity. So the definitions of the energy in terms of both quantity and also quality is very important for us, very crucial and essential. And also the second aspect, second pillar is correlated with the energy equity. For the energy equity, it is more correlated with any kind of how far we can facilitate the opportunity to all of the stakeholders. So we are not only figuring out that we must buy any kind of electricity or the energy from certain producers or any kind of energy generators or etc. But in these terms, in these things, what we are targeting for is that all the stakeholders, whether in conventional one, we are the consumers or the customers of the energy, something like that. We can be any kind of energy provider, we can be any kind of energy transmitters, distributors, or etc. So all the stakeholders must have any kind of equal opportunities to be the player. Especially when we are talking about the renewable energy, because renewable energy is basically thinly and also widely distributed. And if we would like to optimize all the sources of the renewable energy available in our regions or our country, means that we must involve all the stakeholders to be involved in our market. And we need our open market for that. So in these things, energy equity will be correlated with any kind of open market in the future. And finally also correlated with environmental sustainability. And it is not only limited to any kind of CO2 or greenhouse gases emissions, but also we must have any kind of great balance according not only for the gases, but also coverings any kind of soil, water, foods, etc. So we must have any kind of good balance in our nature about that. Next, please. Okay. this is the correlations between the energy pillars, as I mentioned previously, and also with the Sustainable Development Goals, 17 SDGs that we have. Some of them are strongly correlated, but some of them are maybe weakly correlated. Next, please. Okay, this is the energy transitions. And as I mentioned previously, that we are now in the transition period. And we must understand about it. We are targeting to achieve carbon neutrality in 2060, Japan in 2050. Yeah, we don't know whether this kind of plans or this kind of, I don't know, it's like ambitions can be achieved by 2050 or 2060, but minimally we have any kind of motivations to reach that, to achieve that. But as the energy, there is any kind of energy transitions, means that there will be also huge transitions in other sectors, including also the transportations, because transportations finally also correlated with the energy. And however, in case that we have any kind of transitions or any kind of transformation in the energy, means that there will be also huge transformation or transitions in our transportations modes. So we have minimally 4 different energy transformations today. The first one is correlated with any kind of decarbonizations, but it is more correlated to electrification, so power generations or etc. The second aspect is correlated with decarbonizations, but in non-electrified sectors. So it is including also the transportations, the industrializations, or etc. And the third one is correlated with energy productivity. Yeah, some people are defining energy productivity, energy efficiency, and also energy conservations. But actually, they have quite different definitions on that. Energy productivity and energy efficiency is more correlated with the technology that we can have to have high energy efficiency. But for the energy conservation, basically, it talks strongly about our motivation, our will to reduce the energy. That's the energy conservations. And finally, in case that we don't have any capability or capacity to perform first, second, also third ones, means that we must have any kind of scenario to minimize the GHG or CO2 emissions to our atmosphere. And I just would like to emphasize on the definition of the decarbonizations. It doesn't mean that we avoid any kind of carbon-based fuels, no, or any kind of fossil fuels, no. The important thing over here is that how far we can balance. In case that we emit CO2, on the other hand, we must have also capability to absorb the CO2. So that's the definitions of the decarbonization. So we need to create any kind of carbon neutrality in total, not only in one part of our life, but also in total. So carbon neutrality can be achieved by any kind of integrated systems. So it means that from very beginnings, it doesn't mean that we must avoid any kind of carbon-based fuels or carbon-containing fuels. No, we can still use carbon-containing fuels. It is really no problem, because when we are talking about the fuels, chemically we just talk about carbons or hydrogens. But unfortunately, when we use the carbons, means that we produce the CO2. When we use the H or hydrogens, we produce the water. And any kind of hydrocarbons basically contains both carbon and also hydrogens. Next, please. So this is the transformation energy systems that now currently I think we have baseload generations. It's covered by any kind of coal-fired power plants or etc. In some countries we have any kind of nuclear. We have also hydropower, geothermal or etc. And basically for the baseload generations, because it's quite constant, means that the cost of the energy production is very low. Like in Java, I think it's only about 800 rupiah or something like that. So 0.8 cents dollars per kilowatt hour, or minimally only one something like that, or 10 something like that. So, but unfortunately, in the future, what will really happen? So it's that as the coal and also any kind of maybe some conventional baseload generations, there will be any kind of phase down and also phase out, whether it happens in 2050 or 2060, means that these portions of the baseload generations will be reduced significantly. And we only have any kind of nuclear, we only have any hydropower or maybe geothermal. And also on the other hand, when we would like to massively adopt renewable energy, means that at that times we need also to maximize its characteristics. And renewable energy basically is fluctuating. That's the big problems with renewable energy, especially solar and also wind. So in case that we would like to avoid any kind of curtailments from renewable energy, means that we need also to have any kind of buffer systems to cover any kind of fluctuations due to any kind of fluctuation from the renewable energy. So that's once in the futures, the lowest price of the energy comes from the renewable energy, and then followed by any kind of baseload generations, and finally it is followed by any kind of adjusting or any kind of energy buffer. Next please. So when we are talking about non-carbon based fuels, what really happens, what we have actually, now we talk about carbon based and non-carbon based, but in case that we would like to use the energy, I think it's quite more convenience. I think when we ask to you, I think it is more convenient to use electricity compared to any kind of woody biomass or etc. So we are not using any kind of woody biomass further for our cookings in our homes or something like that. Maybe in the future, it will be really convenient for all of us to use electricity or any kind of other fuels. But the problem is that in case that we would like to avoid the utilizations of the carbons over here, what the options that we have currently? So basically we have 4 different non-carbon based fuels over here, including the electricity. Yes, electricity basically, because it is electrical energy, it is not chemical energy. So it means that it doesn't have any kind of carbons or any kind of other elements. The second aspect is, the second options is chemical energy. And when we are talking about the chemical energy, we just have any option for the carbons or hydrogens. So in this case, because it is non-carbon, means that only hydrogens, and also it is derivatives. So derivatives including also the ammonia or etc. And the third option is metal fuels. We can use any kind of iron, we can use any kind of aluminums, we can use any kind of mangan or etc. basically. When we oxidize it, we can get any kind of heat, we can get any kind of energy from that. And finally, we can maybe transform the energy generated from that, the electricity or etc. And finally, also we have options for the heat. The problem is that we have 4 different options for the non-carbon based fuels over here, and how far we can mutually convert them and also utilize them together. So it means that we must have any kind of integrated systems that can facilitate all these kind of non-carbon based fuels in our future. Next please. This is the correlation between the energy and transformation and transportations. As we could see over here, that transportations basically consumes about 1/4 or about 1/4 to 1/3 of the total energy we consume today. And also between that, car and also the passenger cars and also motorcycles consumes largely, and finally also they contribute to GHG and also CO2 emissions largely. That's the problem, that's the correlations. The energy sectors, sometimes we define the definitions of the sectors, including the energy sector, transportation, etc. But in case for the final use or final utilization of the energy, the transportation is very, very huge. It's about 1/3 or minimally 1/4 of the total energy consumptions that we have. And what we need over here is that as the transportation consumes largely of the energy we use or the total energy we have or we generated today, means that we must have any kind of multifunctionings of our transportation systems. So we are not only using our cars for our transportations, but how far we can multi-use of this kind of transportation model. It's very important. So I would like to also introduce some technologies correlated with that. So people will have any kind of options. When they purchase the cars, they are not only buying the car or any kind of transportations model for only transportations, but also they have capability to create any kind of economic opportunity for themselves. Next, please. Yeah, this is the difference between the hydrogens and also battery-based vehicles. As we could see over here, at the left side, we have any kind of battery electric vehicles. Battery electric vehicles, basically the battery itself is installed under our seat. And we could see over here that as the lithium ion battery is basically very heavy, so it is gravimetric energy density is very low, that's problems. And it is very bulky and also very heavy. There's also one advantage of that. The advantages of this one is that the central gravity of the cars is usually under our seat. So it means that it is very, when we drive it, it is very, very convenient and also stable. Because the central gravity is very low and also under our seat. The problems with the lithium ion battery of the car, something like that, is the charging times, cruising distance, and also the price. This price is also still very high. And you could imagine that to drive about 500 kilometers, something like that, means that we need the capacity of about minimally 90 kilowatt hours of the battery. So it is very bulky and it is very huge. And that's the problems with any small cars, especially the city cars, because usually it cannot be loaded with any kind of huge battery. And so on the other hand, on the right side, we have the options for the hydrogen-based fuels. Means that we adopt also any kind of fuel cell systems to convert the chemical energy from the hydrogens to electricity, and then the generated electricity is utilized to drive the motors. So it means that we can drive the cars after that. The problem is that over here is that the hydrogens. So we need any kind of chemical energy stored in hydrogen forms over here, and we utilize the hydrogens to generate the electricity using any kind of fuel cells. So the problem is that sometimes people are asking about the total efficiency. The total efficiency, so we must be careful with this one. And we must also understand the total efficiency that we have. Okay, when we are talking about total efficiency, and we also include the total life cycles of the systems, in terms of the electric vehicles, because we just use the electricity generated from any kind of power plants, so it means that we must also consider the power generation by power plants. So it really depends on the country. Like in Indonesians, usually we have the average of about 35% of the power generation's efficiency. And from that, we have also the efficiency to charge the battery, okay, and then also discharge the electricity from the battery. So in total, we can have any kind of total efficiency for the electric vehicles is about 30%. And in case that the electric vehicles is devised with any kind of regenerative braking technology, so it means that when we brake the cars, we generate the electricity. So the electricity generated from from our braking systems, it can be used to charge the battery. So the total efficiency also will be correlated, will be increased to about 35% or something like that. On the other hand, for the hydrogens, the problem is that the hydrogen usually produced from various resources that we have: renewable energy, natural gases, coals, or etc. And consider like for the natural gases, now currently hydrogen is produced from natural gases. From natural gases, we can have efficiency about 70 or 80%. The problem is that after that, the big problem with the hydrogen is that although it has very high, I think the highest gravimetric energy, it is about 120 megajoule per kilogram, which is the highest gravimetric energy by any chemical energy. The problem is that its volumetric energy density is very low. So it means that we must have any kind of efficient energy storage or an efficient hydrogen storage systems for that. So that's the problem. So the problem starts from that. After producing the hydrogens, we must have any kind of technology. We must have any kind of technological options to effectively store the produced hydrogens. And usually it also takes another efficiency drop. So over here, I think also the total efficiency is still about 30 to 35%. It's quite similar with the electric vehicles also. Okay, next please. This is, I think, the advanced technology for the hydrogens. Because, as I mentioned previously, hydrogens basically has very high gravimetric energy density. And its utilizations, it really depends on that. In case that any transportation modes, including aircraft, ships, trains, or etc., basically this kind of transportation modes, basically they require very high gravimetric energy density, and hydrogens quite match with that. And now what really happens is that like Boeing's, Airbus, or etc., they are working hard to use the hydrogens for their aircrafts. Yeah, now they are adopting also any kind of biodiesel or blah, 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 something like that. But in the futures, because hydrogen has very high gravimetric energy density, in case that hydrogen can be adopted, means that this kind of hydrogen-based aircrafts maybe will be dominating in the future. So maybe we are focusing on after 2040, after 2060 about. And as we could see over here, the history of the hydrogen-based aircraft basically also started quite a long time ago. And it has been also adopted for any kind of rockets engine or etc. And also Airbus is targeting to adopt this kind of hydrogen-based aircrafts in 2035. The problem is that how far we can have any kind of very competitive price of the hydrogens. Next, please. So this is also another options for the hydrogens. We have any kind of ships. We can also in Germany they have adopted also any trains, hydrogen-based trains. So it means that the hydrogens usually can be stored in any kind of compressed gas or maybe liquid hydrogens, and it can be utilized to be converted to the electricity. And then also, as we could see at the bottom left over there, it is the ferry. It is not ferry, it is tanker. It is tanker developed by Kawasaki Heavy Industries, Japan. Because in Japan also we have quite big project. I think that's the largest or the biggest project for the hydrogens. That's the first project also to transport the hydrogens produced from the Australia to Japan. And this kind of ships just been developed 2 years ago. And the biggest project to bring the hydrogens from Australia to Japan will be started from 2025. So we must be really, really curious also about this one. We must also be careful about this one because we have quite huge competitions with also Australia. Australia, they have huge resources for the coal, their brown coal, their young coals. It can be converted to hydrogens cheaply. Very cheap actually. And it can be transported to any kind of demanding countries, especially in Asia. In Asia, we can have any kind of Singapore, Japan, Korea, and also finally also China. Next, please. Okay, this is the characteristics of the hydrogen, but I just would like to skip because I think I will run out of time in case that we discuss in detail about this one. Okay, but I just would like to emphasize on this one. The problems with hydrogen is that it is correlated with the volumetric energy density is very low. So we need any kind of another technologies to store that. Compressions, liquefactions, or maybe any kind of hydrides, metal hydrides, liquid hydrides, or etc. And also any kind of, maybe we can convert it to its derivatives, including ammonia or etc. And that ammonia is also very, very promising because like in Indonesia, we have mature technologies to produce the ammonia, all those from natural gases. So natural gas is converted to hydrogens and then hydrogens is converted to ammonia further. Next, please. It is the utilizations of the hydrogens. We have many options for that. It is not only focused on the transportation for our passenger cars, no. Because for the passenger cars, I believe that electric vehicles, battery electric vehicles will be the winner compared with the hydrogen-based vehicles. Because what? Because it is very convenient. And we can imagine that when we have electric vehicles, what we are targeting for is that in 2023, I think 23 or 24, something like that, we are developing, like in Japan, we have also developed the charging systems that can provide 450 kilowatt charging capacity. So it means that why 450 kilowatts? Because
we need to charge the electric vehicles in only 3 or 5 minutes. And that's quite competitive when people fill the gas, like fill the gas whether gasoline or hydrogen or something like that. So for the passenger cars, basically I think battery electric vehicles will be the winner. But now we are still waiting. We are still waiting for the battery technology. It is not only lithium-ion batteries, conventional one, but also what we are targeting for is for the solid-state battery. Why we use solid-state battery? It is more safer, and also the energy density is about 3 or 4 times higher than conventional liquid-based lithium-ion battery. So, but the problem also is very huge. Now we have also research correlated with this kind of solid-state battery. Because what? Because it is solid, the electrolyte is solid, means that during charging, also discharging, there will be any kind of expansions and also shrinkage. And once the expansion, also shrinkage occurs, we can have any kind of crack. And there will, because it is solid, means that once crack happens over there, the efficiency will drop significantly. So the options for the hydrogen is quite huge. It is including also the transportations, it is also including for the industrializations and also power generations. So in 2030, what we are targeting for is that we are not, in Japan, we are not importing further coals or any kind of carbon-based fuels, but we are importing the hydrogen itself. So we are importing the hydrogen maybe from Indonesia, from Middle East, from Australia, or etc. So we are not further importing coal from Indonesia and also from Australia or etc. So we must really understand about this kind of conditions. There will be any kind of great shift in these 5 or 10 years in the future. Also, next please. This is the mutual conversions of the energy. So we cannot talk about energy, these fuels is only for this one and something like that. We must have any kind of integrated systems for productions, distributions, transmissions, and also finally for utilizations. In case that we would like to have any kind of more higher efficiency from our energy systems. Next. This is a possible roadmap for hydrogen for Indonesia. The big picture is that, over here is that, because the condition is quite different and our maturity for the technology is quite really different, it's quite low compared with other developed nations, means that we can start from export. So it means that we can produce the hydrogen and then we export it to several demanding countries, including also not the Asian also, but also I think European, Germany or etc. And also we can start also from very huge one. Very huge, large-scale utilization also includes any kind of blending or mixing with coal in our power generations, and also maybe blending also with diesel engines, because we can have any kind of blending between hydrogens and also diesel. And basically, in case that we can blend the hydrogens for our diesel engines, basically the performance becomes higher. Because usually the price of the fuels is divided between the ratio of the carbon and hydrogen. As the ratio of the hydrogens increases, means that the price of the fuels increases. And finally, the most important thing is that from 2030, 2040, until 2050, how far we can create any kind of infrastructures for that. That's the biggest things, that's the biggest challenge for that. Some countries now still doing on that, like including Japan, Germany, or etc. Germany buildings, any kind of trains or something like that. That means that infrastructures. And during that period, we cannot say, oh, we can get any kind of economic benefit from that. No. We can have any kind of economic or good economic performance after we can create any kind of hydrogen economy. So maybe it can happen in 2050 in terms of, in case of Indonesian case, something like that. Further, and next please. This is the roadmap. This roadmap also has been proposed to embassy, Indonesian embassy in Japan, and also has been proposed also to our Ministry of Energy and Mineral and Energy. As we could see over here is that hydrogens and also battery technology also has been included over there. We must have this kind of progressive, but also still measurable and feasible roadmap for all of us. We cannot just say, oh, we can have any commitment 2060 for carbon neutrality. No. The big problem is that how far we can translate this kind of motivation, this kind of ambitions to any kind of detailed roadmap. And it is very achievable. It must be achievable. It must be feasible, achievable, but still progressive. Next, please. How long I still have? 15. Okay, this is the hydrogen-based vehicles. The history also is quite long. And also vehicle types also, but okay, because I just only have 15 minutes. Okay, next please. Okay, also, this is the fuel cell-based vehicles. So basically, fuel cells convert the fuels, in this case, it is hydrogens, directly from chemical energy to electrical energy. The problems, because I'm mechanical engineering, I'm usually talking about the thermodynamics. The problems in our system, why our energy systems, why in transportations, the efficiency is very low. It's about 20%, 25%. Because what? Because we always deals with any kind of heat or thermal energy. When once we deal with any kind of thermal energy, the efficiency will drop significantly. So in our idea, as long as we can convert directly the chemical energy to any kind of electricity or any kind of power, mechanical energy or etc., means that we can have significantly higher energy efficiency. So that's the things. When we are talking like, I don't know whether you are quite familiar with the terms of the exergy. Exergy means that the capacity of the energy resource to provide the usable energy. So we are not only buying the energy source, but we are buying the capacity of the energy resource to be provided, to be usable for us. The usable energy from the resource, the usable energy from the coals, the usable energy from the natural gas. So the problem is that, like natural gas, coals, or etc., or oil, or something like that, we must understand why the price is quite different. Because for the usable energy, final energy that can be utilized is really different. So the price will be different. That's the main idea when we define the price of the energy. It's not correlated with any how much the energy available there, but the important thing is that how much the energy can be utilized by us. So in these things, fuel-based electric vehicles or etc. is very important. So it means that in case that we would like to increase the efficiency of the vehicles, we must use any kind of direct technology to convert the chemical energy directly to any kind of mechanical energy or any kind of electricity or etc. Next, please. This is the internal combustion engine-based vehicles using the hydrogens. Yeah, like Toyota also have developed this kind of vehicles. So it means that hydrogen is directly injected to the engines and it is combusted, it is burned, although the efficiency is quite low, but it can run. So it means that we don't need any kind of further improvements or any kind of replacements of the engine itself. Next, please. This is topologies of the fuel cells, but I don't want to talk in detail about that one. So please, next, please. This is also dual fuel engines between the diesel, gasoline, also the hydrogen. It's very possible. It's very possible. Until about 30%, practically it is really possible. Also, in case that we have any kind of diesel-based power generations, means that we can also inject the hydrogen over there. And the efficiency will increase significantly. Next, please. This is the challenges. Challenges in the implementations, including the lifetimes of the fuel cells, also the safety of the hydrogens or etc. The problem with the hydrogen is that because it is the smallest elements. The smallest elements means that it can easily leak. It can easily leak. And also there will be any kind of embrittlement. Because what? Because it's very small. The elements are very small. And in case that maybe it is trapped in several materials or piping, something like that, and there will be any kind of concentrated over there. They will be concentrated over there, and finally there will be any kind of embrittlement. That is usually called as the embrittlement. Once embrittlement happen over there, there will be any kind of risk for the crack. So we are still dealing with any kind of problems with that. Storage, transportations, and etc. The safety basically related to hydrogens. But I just want to underline that the auto-ignition temperatures of the hydrogens is basically very high, 600 degrees Celsius. It is about 3 times of the gasoline. Gasoline is only about 253 degrees Celsius. So it means that when we have any kind of gasoline cars and the tanks itself, the temperature is quite high, reaching about 250, there will be any risk for auto ignitions. But for the hydrogens, basically, its auto ignition is very high. It's more safer in terms of the auto ignition temperatures. The problem is that auto ignition's energy is very small. So we must distinguish between the characteristics. So how far we can improve the safety standard for the hydrogen, for the ammonia, or any kind of fuels, I think there will be a great challenge in the future, especially when we are talking about applications of the hydrogens for aviation, for the aircraft, or etc. Next, please. Okay, this is utilizations. As I mentioned previously that things like electric vehicles, hydrogens, or hydrogen-based electric vehicles, or etc. Basically, they are not only serving as a transportation device, but also it can be utilized as the another utilization, including for the energy service, or etc. Next, please. This is a produced EV, electric vehicles. As we could see over here, basically all the manufacturers, they have ambitions to create electric vehicles. The problem is that how far we can follow that, how far also we can reduce the price. But actually, the first electric vehicles was massively produced in 2009. The first manufacturer was Mitsubishi Motors. They produced any kind of IMF cars, and then was followed by Nissan. So Nissan Leaf followed Mitsubishi in 2010. And after that, any Tesla or etc. But we could see over here, now the price of the battery drops to about 20% of its initial one. So when electric vehicles was massively produced, the price of the battery itself per kilowatt hour was about $1,500 US. But now per kilowatt hour, it's only about $300 US. So we can imagine it's only about 20% of one. So once we are able to produce the solid state battery in 2028 or 2030, the price of the battery basically will drop down significantly further. Next, please. This is the countries and also manufacturers' commitments. All the countries, basically in Europeans, they have commitments to shift to electric batteries, to electric vehicles, including the batteries and also hydrogen-based electric vehicles. Next, please. Yeah, this is the automakers. Next, please. Yeah. The problem is that sometimes people are talking, when we have electric vehicles, when we have hydrogen-based electric vehicles, I think how far we can charge, how far we can have any kind of risk for the flood, or etc. when we face the water or something like that. But actually, it has been, every problem has been anticipated. So as mentioned previously, people are imagining that, charging electric vehicles needs a time. Yes, it needs time. But also we have technology to cover that. Now the average fast charging systems usually have capacity of 50 kilowatt, and we can charge about in 30 minutes for full charge. And as mentioned previously, for CHAdeMO and also combo standard, charging basically have 3 different standards. CHAdeMO, basically developed by Japanese companies, combo, basically by European companies, and also Tesla. Yeah, basically, China also has another new charging protocols, charging standard, but it is basically based on CHAdeMO standard. So we can include in CHAdeMO standard. So CHAdeMO has commitment for maximum capacity of 450 kilowatt. So we can charge in 3 minutes, 5 minutes, something like that. So it can be fully charged. Combo now currently about 220 kilowatt. Tesla about 180 kilowatt. So in case that we can use this kind of very fast charging systems, means that we can charge in less than 10 minutes or 20 minutes during charging. Next, please. The also another opportunity is correlated with how far we can multifunctioning the electric vehicles, including the hydrogens and also battery-based electric vehicles. So as we could see over here, basically all the electric vehicles produced after 2009, 2010, basically they are devised with any kind of communication systems. You can imagine, like Nissan Leaf produced in 2010s, all the data, all the travel data basically stored in Nissan's database. So it is really big data, and we can analyze that. So we can analyze that. So it is really big data, and this kind of transportations and also any kind of communication systems has been devised well in the vehicles. And finally, once we can control that, when we control the charging system, the control inside the cars or inside the vehicles, means that we can do anything. Charging, also discharging of the battery or etc. Next, please. So this is multi-conditioning the electric vehicles for all of us. So basically electric vehicles is battery. It consists of battery and also motors. And the battery is very huge. It is about, minimally it's about 40 kilowatt hours. And for the standard one, I think today is about 60 kilowatt hours. And for our homes, basically we just consume about 1.5 kilowatt hours per day. Yeah, it really depends on the size of the homes. But actually, we just consume about 1.5 or 2 kilowatt hours per day. So it means that in case that we have electric vehicles, we can have about 1 week or 2 weeks or about 10 days to cover our electricity of our homes. So it means that electric vehicles basically, when we have the battery over there, it can be charged and also discharged. So by facilitating this kind of characteristics means that we can use the electric vehicles to provide any kind of ancillary service to the grid. Ancillary service means that we can provide any kind of additional service to the grid. So we can absorb the electricity in case that there is any huge surplus electricity in the grid, or maybe we can deliver that. Next, please. So this is the system that we have developed. We have quite big projects in Scandinavians. This is Denmark over there. Why Denmark? Denmark is really flat countries. So it means that it is really difficult for Denmark to provide or to build any kind of energy storage, electricity, especially the electricity. So it is very, very difficult for them to build any kind of pump hydro. Now Indonesia is, I think now is still constructing the pump hydro, the PLN. The capacity I think is about 1 gigawatt, something like that. And what we are targeting for is that because in Denmark, they cannot build any kind of pump hydro over there, so they need any kind of power support. And their renewable energy basically about 150% higher than their demands. So it means that their energy is very fluctuating. That's the big problems. So they need any kind of energy buffer. Okay, so by utilizing this kind of technology, actually we can use the electric vehicles to help the grid, to assist the grid, to provide ancillary service to the grid. Okay, and we have also the opportunity. So in case of Denmark, we can provide about, I think it's about 3 million rupiah, 3 million rupiah to all of the EV owners. So we can have that. So it is passive incomes, although it is not so big, but monthly is about 3 million rupiah, something like that. So we can control that by developing any kind of system over here. So we call it as the aggregation system, aggregators. We build any kind of aggregation systems. You can imagine it's like Telkomsel, XL or something like that. So basically aggregation system or aggregators can communicate to both parties, to any kind of energy providers like PLN or etc., and also to communicate to all of the electric vehicles. So electric vehicles, they have contract with aggregators, and they can be, as long as they are distributed and they are connected to the grid, to the chargers, whether it is at home, at the office, they are at the shopping mall or etc., as long as they are connected, it means that they can do any kind of service. So they can charge, they can be discharged. And once we get any kind of electricity down, it means that regulations down surface means that we can have any kind of mainly free electricity for our vehicles. Next, please. Okay, this is some services available for that, but I don't want to talk in detail about this one. Next, please. This is the impacts and challenges for vehicle to grid technology, or some people call it as the vehicle grid integrations. We still have some problems correlated with the technology and also with the standards, with the everything. But we are targeting for in 2030 we can have this one. Otherwise, in case that we cannot control this kind of electric vehicles, means that it will be the huge load for our electrical systems, our grid. You can imagine, like in case that in Indonesia we have 1 million electric vehicles, and half of that, 500,000 of electric vehicles are charged simultaneously, we need additional 5 gigawatt of electricity. The problem is that, not on that, the biggest problem is that because they are fluctuating. So it means that the burden, the load to our electrical grid is very huge. We can minimize this one. We can minimize, and we must minimize that. Otherwise, there will be any kind of great negative impacts to our grid. So from the beginnings, we must be able to control charging, also discharging behaviors. The second one is that in case that we have ability to control that, it's really better to include them to support our grid. So electric vehicles will be not the load further for our grid, but also it can be any kind of assist. It can provide any kind of services to the grid system. Not only to store the energy, but also to provide, absorb the energy, or etc. Next, please. This is the projects that we have in the globes actually, and we have big project in Japan starting in 2010, that the first VGI projects in the world, and also the last project that we have is in Denmark, that also the biggest projects that we have in the world until 2019. Next, please. This is V2G services Indonesia. We have started there. Next. Okay, next, please. I think we are quite familiar with our conditions of our electricity, and this is quite fluctuating. And next, please. And this is the impacts of in case that we adopt the electric vehicles to assist, to help, to provide any kind of ancillary service to the electrical grid that we have. So it means that in case that we can control them, they basically can absorb the fluctuations happens in our electrical grid. And maybe it is still necessary to build any kind of pump hydro or etc. But basically, in case that we have really matured technology for that, we don't need to build any kind of buffers, energy buffer system for that, including the pump hydro, including the battery or etc. because they are quite expensive. Next, please. So this is the frequency. Our electricity is basically quite bad. The frequency fluctuation is very huge. So we can imagine that we are having a frequency of 50 hertz, and you can imagine that it can fluctuate about 0.5 hertz, and that's very big. And sometimes we can find the problems in the companies, in the industry, something like that, because it deals with any kind of motors, it deals with anything. And frequency basically used as any kind of standard for the energy delivery. Next, please. In case, before that, written back. Okay, this one. So, in case that we adopt the electric vehicles in our systems and we are able to control that, there will be any kind of opportunity to all of the owners or drivers of the electric vehicles. So we can enjoy any kind of regulation up service and also regulations down. The problem is that how far we can create any kind of open market to all the energy system that we have. Once we can create that, all the stakeholders, basically they can enjoy this kind of regulation services. Regulation up and also regulations down. You can imagine that, like in our case in Denmark, for this kind of service, basically we can get any kind of 100 to 10 times of the electricity price compared to any kind of conventional electricity delivery system. So in this case, we can enjoy really high price of the electricity. Not the electricity, price of the electricity that we sold to the customer, but the service fee from any grid services, including the PLN or etc. Next, please. Yeah, I think this is the last one, I think. So this is the V2G challenges and also barriers in the Indonesian case that I assume. So we have some problems actually, including the low electricity quality. Yes, sometimes we heard that, oh, our electricity in Java or Indonesia is really sufficient. Basically not. So sufficient in terms of the quantity, yes. But in terms of the quality, it is really different things. So we must be really understand that in terms of the energy, we must have definitions of quantity and also quality. So in this case, when we talk about the quality is very bad. The problem is that once we adopt massively the electric vehicles and we don't have any capability to control them, it means that the quality will be worsened. We're getting I think it will be worsened further, and I think the frequency will be much more fluctuating. And also, we have also low balancing capability, also our driving styles, our congested electrical grid. Yeah, this kind of congestion is also very crucial for all of us. Next, please. I think this is the last one. Okay, thank you very much for all of your attentions. So in case that you have any questions or any interest to all of our research, we are welcoming for that. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Check. Thank you, Dr. Aziz, for very great presentations about integrated energy and transportation system towards sustainable future. I just want to emphasize one about the energy triangle. You mentioned that the first pillar is the energy security. And we need to make sure that energy security is not about talking about the quantity or the ability to get access to the energy, but also how good the energy is or the quality of the energy. And then the second pillar is the energy equity, and the third pillar is environmental sustainability. Okay. We still have a time for the Q&A. Now I open the first session for the Q&A. Maybe first session for two person to ask directly to Dr. Aziz here. Okay, is there anyone? Just raise your hand. Okay, one on the left, and once more.
You need 3 or 2, sir?
Two.
So,
okay.
Two from there, and then there is one from here? So?
Yeah, one from there and one from the cadet behind there.
All right.
Okay. So, please say your name and pose your question.
Check. So let me introduce myself first. My name is Desa Dian. I am a cadet of Aviation Polytechnic of Surabaya. And this question actually about general technology. And it is said that in generation 5.0, there will be a freedoms to innovate in technology. And with the current state of technology that already increased everywhere around the world, will there be a possibility of massive chaos of technology, and how to solve this possibility? Thank you.
Can you say again the question, please?
So my question is, it is said that in generations 5.0, there will be a freedom to innovate in technology. And with the current state of technology that already increased everywhere around the world, will there be a possibility of massive chaos of technology? And how to solve this possibility? Thank you.
Okay, thank you, Cadet Desa Dian, for the question. Second question, please.
Right away, sir?
Yeah.
Okay.
Thank you for the opportunity. First, let me introduce myself. My name is Arif. I'm from Land of Transportation Polytechnic Bali. Remember Dr. Muhammad Aziz as the presenter past a month ago. Nice to meet you again. Very interesting presentation from Dr. Muhammad Aziz. I want to question about the can Dr. Muhammad Aziz be share about what Japan doing in the application of sustainable energy, especially renewable energy. And we know Indonesia have a lot of resources to implement the renewable energy. What is the key point to implement that? Thank you.
Okay, thank you, Mr. Arif. Question about the best practices in Japan about renewable energy. What is the key points? Dr. Aziz, please.
Okay, thank you very much. Let me to sit down while I'm answering. The first question is correlated with any kind of technological fails, chaos, and also freedoms, something like that. When we adopt any kind of society or society 5.0, industry 4.0. Okay, basically we have any kind of high freedoms for developing our creativity, for our ambitions, or etc. But again, when we develop the technology, we need any kind of standard. So we cannot adopt massively the technology while we don't have any kind of standard on that. So you cannot imagine that, oh, I just developed the technology and the technology can be used by myself. If for using myself, it's really no problem. So when we are dealing with any kind of other peoples, when we are dealing with any kind of community, and it will be sold, it will be available commercially, basically we need any kind of license, we need any standards. That's the problems, the standards. So standards correlated with any kind of technological standards, technical protocols, or etc. And finally also it covers also the safety standards. So yes, we have any kind of freedoms on that, but also we need to respect any kind of standards, any kind of regulation, and rules during the implementations. And the second one is correlated, okay, there will be any kind of huge technology, and whether it will be any kind of chaos, any kind of fails, or etc., there is any risk of that. I believe that. You can imagine it's like blockchain technology. It is quite distributed ledger technology. Blockchains, artificial intelligence, or etc. Whether this kind of technology, there are many options, many levels of the artificial intelligence. Like for the artificial intelligence, basically it is rooted with a kind of big data technology. So we have any kind of big data. You can imagine it's like in Japan, when we travel with any trains, means that all of the data are basically recorded. As I mentioned previously also, that the driving history of the Nissan Leaf owners from 2010 until now, until today, as long as the cars is driven by any owners or drivers, basically all the data is recorded. So the problem is that whether we can keep this kind of data anonymously, safety, or etc. Yes, there will be any kind of problems, maybe any kind of hijacking, any kind of hacking or something like that. There will be any kind of risk of that. But finally, how far we can tackle down those problems. And also for the blockchain technology. Blockchain technology, okay, some people are working on that. Some big people are how to communicate, how to have any kind of distributed ones, something like that. But in case there will be kind of faults, any kind of fault in the systems, we don't know. Some people are working to hacking that problems. Yeah, blockchain technology basically can minimize this kind of hacking or hijacking systems, basically. Because what? Because it is distributed. So, in case that we cannot hack or hijack all the systems distributed over years, means that we cannot completely down this kind of systems. That's the blockchain technology. But also, the problem is that, how about the communications? We can have any kind of, this kind of blockchain technology which basically can be applied in many applications, including also in our mobile systems, in our electrical systems, or etc. So finally, in case that the communications cannot be transferred well simultaneously, that's also the big problems. The chaos, when we define the faults and also the chaos, I think the chaos may be after getting any kind of fault, there will be any kind of chaos. But for the technology, the chaos among the technologies, I think is quite small, because we are dealing with any kind of standards. So before being implemented, I mean, each technology must be standardized well. And the standard not only cover any kind of physical standard, but also the protocols. The protocols including the soft one. So how the technology can match other technologies well. This kind of protocol is also very important. That's one. But the second question is correlated with any kind of best practice of the renewable energy. Yeah, now currently, I think Japan is quite similar with Indonesia. So it is really different with the European case. In Europeans, they can enjoy a very predictable renewable energy. But in Japan and also Indonesia, we cannot have any kind of good, predictable renewable energy. Why I say like this one? And it's very important. Some people don't understand about that. Like in Europe, because there are big continental, means that their winds and also their clouds or something like that, basically is quite stable. And we can predict well. We can have any kind of supercomputers based on any kind of AI, artificial intelligence, based on the big data that has been recorded for 5 decades, 50 years in the past, something like that. And we can predict that, we can forecast. But unfortunately for Japan case, we cannot. Because what? The fluctuation is very huge. It's very high. So, yeah, we can predict, but the accuracy is very low. Also, including the Indonesia. Indonesia is basically also tropical countries. And okay, some people are, maybe we understand that, oh, we enjoy very long solar times, I mean sunlight. The sunlight, oh, we can enjoy about 12 hours per day, something like that. But the problem is that the humidity is very high. And you can imagine that once what we need for our solar panel is that high intensity or direct sunlight from the solar. It's not the distributed one. So once we have any kind of high humidity in our atmosphere, or we have any kind of water in our atmosphere, means that the sunlight from the solar is dispersed. When it is dispersed, the intensity reaching the solar panel is very low. So although we enjoy very longer times for sunlight, unfortunately the intensity reaching our panels is very low. And also for the wind, because we are tropical area, basically our wind speed is very low. We must understand about it. We really compare with the northern part of the Europeans, like Germans or Germany's, Netherlands, and also some Scandinavian countries. Basically, their wind speed is about 3 times of us. And we must understand that because we are in tropical area. Tropical area, basically, the temperatures between the north and also southern part of the countries are basically quite similar. So winds basically moves due to the temperature difference. So although we have any kind of winds, unfortunately the wind speed is really, really small. So in terms of Japan, what we are adopting now is that in northern part of Japan, we have big wind farms. But the problem is that, like Hokkaido in northern part of, it is quite similar also with the German. In Germany, actually what really happened is that the wind farm, the largest wind farms is located in the northern part of the Germany. And unfortunately, the grid connecting the northern and also southern part of the Germany is quite limited. So it means that not all the electricity generated from the northern part of Germany can be delivered to the southern part. While the demands for the electricity, the highest demand of the electricity is located on the southern part of Germany. The huge industry is basically in the southern part. So it is quite similar also with Japan. Japan also, we enjoy any kind of high power generations or electric generation from winds in northern part of Germany, northern part of Japan, especially Hokkaido Islands. But unfortunately, the grid connecting between the Hokkaido and also Honshu Islands, like including Tokyo, something like that, is very limited. So finally, some wind farms in northern part of Japan and also Germany, they are stopping. The problem is that once this kind of wind turbines is stopped, basically it is, we have any kind of mechanical brake pad for that. Once this kind of wind turbine is stopped, means that the brake pad for that usually will be getting broken. So now currently what we are adopting is that we are converting the surplus electricity that cannot be delivered from the northern to the southern part of Japan to hydrogen, and then hydrogen is shipped, or maybe we can deliver by other means of transportations, but basically by ship. It is shipped to Tokyo, it is shipped to Osaka, or etc. So as I mentioned previously, that for the renewable energy, because it is fluctuating, so it means that we need to buffer that. And also we need to convert to more any kind of adaptive energy storage, including the hydrogens, ammonia. Battery is basically very expensive, it's very bulky, it's very heavy. So it means that we cannot use the battery for that. Yeah, we can use any kind of battery like redox flow battery. I think Indonesia is not, has not adopting this kind of redox flow battery. Redox flow battery is basically also very, very economically promising because it is quite cheap. The capacity is quite huge. The problem is that it should be stationary. Yeah, it cannot be any kind of mobile battery, no. But it is basically redox flow, so it means it's flowing battery. In Japan, we adopt this kind of redox flow battery for also to absorbing the surplus electricity. So I suggest also in the Indonesian case that we must understand our characteristics. So what I'm really having any kind of, I'm worried about is that in our newest roadmap for the energy, we will adopt very huge amount of solar power. And I don't know who people make this kind of roadmap. It is very dangerous in case that we don't have any kind of capacity to buffer this kind of fluctuations from the solar, means that our grid will down. That's the big problems. So because solar is basically very, very fluctuative. Wind is not so fluctuating, but solar is very, very fluctuating. So it means that we must have any kind of capacity or buffer capacity to cover that. And also like wind energy, blah, blah, something like that. I think it is really better to characterize that well. And also for the energy storage, and also for the other technologies, I think. Thank you very much for your questions.
Okay, thank you, Dr. Aziz, for the explanations. Maybe the next session for one participant to ask Dr. Aziz, is there any? Okay, please.
Where are you, sir?
Yeah, can you raise your hand, please?
Okay.
Thank you.
Thank you. Can I ask in bahasa?
Sure, please.
Oke,
Silakan,
thank you.
Mas.
Ya. Makasih Bapak Prof Aziz dan Bapak Moderator. Perkenalkan, nama saya Bambang, saya dari Prodi Telekomunikasi dan Navigasi Udara. Kami sangat tertarik sekali dengan topik renewable energy. Tadi dijelaskan bahwa tentang renewable energy ini banyak energi alternatif pengganti energi yang berasal dari fosil. Jadi salah satunya tadi pakai baterai ya. Cuman di sini pertanyaannya saya bukan terkait energi alternatif dari baterai. Kebetulan bidang kami itu di frekuensi gitu ya. Kami ingin menanyakan mungkin bagaimana perkembangan penelitian tentang renewable energy dengan gathering energi yang berasal dari frekuensi. Di mana kita dalam kehidupan sehari-hari, di sini pun kita itu dilewati oleh berbagai frekuensi ya. Yang ingin kami tanyakan, bagaimana perkembangan tentang gathering energi yang berasal dari frekuensi khususnya di negara Jepang? Apakah itu berpotensi untuk dikembangkan, sedang dikembangkan, atau sudah ke depan gitu untuk gathering energi dari frekuensi? Seperti mungkin pemanfaatan frekuensi-frekuensi yang lewat di sini untuk charging HP begitu, atau mungkin dimanfaatkan pada penggunaan yang lain. Terima kasih Prof.
Baik, terima kasih Pak Bambang atas waktunya. Silakan Dr. Aziz.
Which one is a little better, to answer in Bahasa or English? Which one you prefer there?
So please in Bahasa, because he said that he's passive English, sir.
Terima kasih. Nah, terkait dengan energy harvesting dari sebenarnya bukan dari frekuensi ya. Karena frekuensi itu sebenarnya unit saja, maksudnya dia bukan sesuatu unit energi. Gitu ya. Frekuensi itu kan hanya berapa satu second itu berapa kali gitu ya. Gelombang itu berapa kali gitu ya. Jadi itu sebenarnya tidak ada hubungannya dengan energi. Nah, memang dalam energi itu ada gelombang, itu juga membawa energi. Gelombang itu membawa energi. Yang akan kita harvest daripada itu adalah energi yang dibawa oleh gelombang itu sendiri. Jadi bukan frekuensinya yang kita harvest, bukan. Gitu ya. Tapi energi yang dibawa oleh gelombang itu sendiri. Gitu ya. Nah, permasalahannya adalah energi itu ada hukum energi kekekalan. Ya, kalau kita mau mengharvest dari gelombang yang ada, ya, saya nggak ngomong pakai frekuensi, tapi gelombang saja. Kalau gelombang itu dia didefinisikan sebagai sesuatu yang memang disampaikan. Jadi ada energinya di situ. Nah, kita memang bisa mengharvest itu, kita bisa memanen itu. Cuman permasalahannya adalah kita mau memanen apa sebenarnya? Kita mau mengkonvert energinya apa? Kalau memang itu signal yang memang akan disampaikan, gitu ya, misalkan ke mobile kita, terus di tengah jalan kita menyerapnya, ya otomatis ke HP kita nggak akan nyampe sinyalnya. Itu jelas. Itu hukum kekekalan saja, gitu ya. Ada mungkin yang ditanyakan adalah energy transfer. Wireless energy transfer mungkin yang ditanyakan, saya kira seperti itu. Ya memang ada wacana untuk mengharvest, ini wacana terbesar sebenarnya. Mengharvest energi ya dari luar angkasa, kita memasang solar panel di atas, setelah itu transmit dengan wireless ke bumi. Itu bisa, itu memungkinkan sekali. Cuman permasalahannya efisiensinya sangat-sangat rendah sekali, gitu ya. Nah, yang sekarang adoptable yang sudah dipakai adalah wireless charging, baik untuk handphone kita atau sebenarnya yang kapasitas terbesarnya adalah untuk mobil listrik. Untuk mobil listrik kita punya satu pack charging itu sebenarnya 4 kW. Jadi 4 kW itu ya sebenarnya Kalau di Indonesia mungkin sekitar 2 sampai 3 rumah itu bisa gitu ya. Jadi kenapa kita aplikasikan di mobil listrik? Targetnya adalah mobil listrik tidak perlu nanti ngecasnya pakai kabel atau dia harus berhenti, tidak. Jadi kita pasang saja chargernya di jalan gitu ya, chargernya di jalan, dan nanti mobil di atasnya dia lari sambil ngecharge, itu bisa, tidak masalah sama sekali. Di beberapa negara memang kosnya mahal, tetapi di beberapa negara sudah ada, termasuk Korea, Jerman, di Jepang juga ada. Itu memang memakai kereta atau bus. Itu ketika dia berhenti, paling berhenti sekitar 3 menit atau misalkan 5 menitan lah untuk menaik atau menurunkan penumpang. Nah, ketika itu dia ngecas. Jadi antara lantai bus dengan aspalnya itu kita pasang wireless charger. Nah, itu yang mungkin seperti di HP itu sama sebenarnya, pada dasarnya sama, konduktif sebenarnya. Induktif charging sebenarnya. Nah, kita memakai seperti itu wireless. Nah, konsepnya sebenarnya hampir sama. Cuman permasalahannya adalah gelombang seperti apa yang akan kita pakai. Microwave atau misalkan apa, macam-macam. Ya sebenarnya yang akan dipakai dari luar angkasa ke bumi itu sebenarnya microwave. Nah, cuman permasalahannya tadi, kita masih menghadapi masalah dengan efisiensi. Di satu sisi itu mungkin ada kemungkinan ketakutan terkait dengan radiasi, terkait dengan yang lain juga, itu ada. Tapi untuk charging electric vehicles, mobil listrik, itu sudah kita adopsi. Tadi saya sebutkan bus ketika berhenti dia akan nge-charge, baterainya dia diisi dalam waktu 3 menit, 5 menit. Setelah itu dia jalan lagi, mungkin jalan ke halte berikutnya sekitar 10 menit, dia ke-charge lagi. Kereta juga sama seperti itu. Kereta di beberapa kereta Jepang juga seperti itu, ya. Terutama yang light transport, ya. Untuk LRT kita ada yang seperti itu, nge-charge ketika berhenti 3 menit, 5 menit. Baru setelah itu jalan lagi, jadi kapasitas baterainya bisa kita perkecil. Itu ada seperti itu. Nah, tapi memang pemakaiannya masih agak terbatas, ya. Jaraknya juga masih belum bisa sampai berkilo-kilo, itu belum bisa. Paling berapa senti saja. Paling kalau mau bus itu paling sekitar 50 sentian maksimal. Nah, karena memang semakin jauh, masalahnya adalah loss-nya itu semakin besar. Berbeda dengan kabel. Kabel tetap ada loss. Loss-nya itu kan R-nya saja, resistance. Gitu ya. Nah, kalau ini loss-nya besar, leakage dari gelombang tadi itu juga lumayan besar. Dia keluar itu banyak. Jadi yang diambil itu paling dia dengan efisiensi dengan jarak sekitar 50 sentian, mungkin dia efisiennya sekitar 85%. Sedangkan kalau ngecas dengan kabel itu paling kita bisa satu arahnya itu bisa mendapatkan sekitar 95%. Itu mungkin jawaban dari saya, Pak. Terima kasih.
Baik, terima kasih Dr. Aziz atas penjelasannya. Demikian ya Pak Bambang, mudah-mudahan terjawab. Kalau masih belum puas nanti dilanjut dengan berkorespondensi dengan Pak Dr. Aziz. Saya rasa emailnya juga sudah diberikan untuk kontak lebih lanjut. Okay, once again thank you very much Dr. Aziz, and we give applause to Dr. Aziz for a very great presentation. I think we arrived at the final of our discussion. So from this morning we have been discussed about the aircraft corrosion, and then continued with the electrical for homes appliance using alternating current and direct current, and finalized by Dr. Aziz explaining about integrated energy and transportation system towards sustainable and towards sustainable future. Once again, thank you very much for your kind attention, and hopefully we all of us can learn something fruitful from here, so we can enhance our knowledge or maybe our experience as well. And once again, thank you very much. I am Ahmad Bahrawi, and see you on the next Icateas. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, and please give a big round of applause once again. Sir, can you please remain on the stage, because it's time for you to receive a plaque or a token of appreciation from Politeknik Penerbangan Surabaya, and this token of appreciation will be given by Pusat Kepala Oh sorry, I'm sorry. I mean will be given by Kepala Pusat PSDM Perhubungan Udara, Dr. Insinyur Heri Sudarmaji di AQYA. Mr. Heri, please I invite you to come on the stage to give this plaque or token of appreciation to our keynote speakers. Actually, we got 3 token of appreciation for all the keynote speakers, but unfortunately, the 2 others are joining us virtually. So we will give this token appreciation to Dr. Engineer Muhammad Aziz as the Associate Professor Institute Industrial Science at the University of Tokyo. This time I'm not going to be wrong again. All right, 3, 2, 1. The next one is the certificate. All right, please give a big round of applause. Not forgetting the 2 other keynote speakers. Thank you very much as well to the moderator, Mr. Bahrawi. We may have a photo session together, maybe? Yeah, while holding the fundal or the token of appreciation. Can we have a photo session together, 3 of you, with the certificate, please? Miss Cadets, okay. All right. To the center, yeah. Okay, 3, 2, 1. Again, it's done. Thank you very much, Mr. Bahrawi, Mr. Heri, and also our keynote speaker, Dr. Engineer Muhammad Aziz. Thank you very much for your brilliant presentations. All right. Okay, ladies and gentlemen, thank you very much for still staying up and not falling asleep until now. I found all of you, maybe some of you are falling asleep during these seminars, but now let's stand up together because our event today will come to an end. Oh yeah, we got a selfie right there. So special. So today I'd like to say thank you to all of you, the excellencies, the distinguished guests, the cadets, all the participants of today's Icateas and also Snitp. Thank you very much for joining our seminar. But I'd like to give you some message from the committee that after this event is being closed, please, all of you, all the participants, go to the photo booth. So the photo booth is located at the outside of this Gedung Serbaguna. You may go outside and then you can turn left. So you can take so many pictures, as much as you can, as nice as you can. And then all the participants can prepare yourself to move into Shangri-La Hotel to get and to have a parallel session. Am I right? Okay. And for the VVIPs or the excellencies, you may remain on this building because we will have lunch together. But beforehand, I will say thank you very much once again. Please give a big round of applause for all of us. We got plenty discussions and all of them are brilliant. So thank you very much for the keynote speaker, Dr. Engineer Muhammad Aziz, and the other 2 keynote speakers who are virtually joining us with a different time of zone of time, and then maybe all of them are sleeping tonight in their respective country. And today, I'd like to say thank you again to the committee for handling this event so very, very well. So last but not least from me, I'm Firda Brillianti. Thank you very much for your attention. I'm so honored to be your master of ceremony, and last but not least, here is the Icateas Technology and Innovation Research Enhancement for the Future of Global Smart Transportation, as well as SNITP, Kolaborasi Kreatif Digital dan Industri Teknologi Transportasi Udara. See you and have a nice day. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Mohon izin Bapak Ibu hadirin sekalian kepada Bapak Heri Sudarmaji didampingi oleh Kepala UPT dan narasumber kita, boleh kita berfoto bersama kembali ya Bapak. Kita bakal taking picture together. Jadi untuk seluruh pejabat mulai Kepala UPT di lingkungan BPSDM Perhubungan juga bisa mendampingi narasumber beserta Bapak Heri untuk ke depan. Untuk fotografer bisa bersiap-siap. Mohon izin boleh langsung ke atas panggung Bapak.
Can I join? Please all of the distinguished guests, Bapak Ibu, monggo untuk foto bersama. Monggo. Oh, ada yang di atas juga. Boleh diarahkan siapa yang ingin di atas? Oke, panitia yang akan ada di atas. Saya boleh di sebelah mana? Oke. Oh, inge, siap. Silakan monggo untuk kadetsnya. Teman-teman taruna untuk ikut foto bersama juga. Seluruh taruna ya, boleh. Paduan suara juga boleh ikut. Mas Niam, oke. MC-nya juga boleh ikut apa enggak? Oke, teman-teman taruna boleh di belakang ya, belakangnya panitia. Karena teman-teman tinggi menjulang. Yang teman-teman padus juga. It is gonna be super wide. Masuk gak? Boleh squeezing agak merapat. Oh, supaya masuk frame semua Bapak. Non sewu supaya masuk frame semua. Jadi excellencies boleh duduk di tengah. Di belakangnya baru ini ya. Tamu nggih. Oke. Tamu boleh di belakang. Iya. Untuk semua yang ikut foto boleh izin untuk melepas masker dulu Bapak. Boleh ya, sejenak melepas masker. Oke. Teman-teman taruna juga ataupun panitia mungkin yang masih memakai masker boleh dilepas supaya kelihatan cetar, cantik dan cakep. Oke, boleh agak dipepet lagi, geser lagi. Yang belakang boleh agak serong dan mepet. Oke. Kursinya kurang. Ada lagi. Oke. Yang belakang lebih nyerong Teman-teman, Bapak, Ibu, panitia, oke. How? Yang oke. Oh, kasih. Saya MC boleh ikut apa enggak? Tangan kanan take off. Iya. Tetap kanan ya, walaupun di sebelah kiri. Gimana prestasi kita bisa.
Suaranya dikecilkan dikit Mas. Mohon izin Bapak Ibu dan adik-adik taruna, bila mana Bapak Kapus menyampaikan jargon BPSDM Perhubungan, prestasi kita bisa. Bisa? Berkenan kita coba dahulu. BPSDM Perhubungan, prestasi kita bisa. Siap. Siap, izin Bapak.
Ya, oke. Ya, oke. Ya. BPSDM Perhubungan, prestasi kita bisa.
Ada tambahan, dilanjutkan dengan Poltek Bang Surabaya, boys rek gitu.
Oke, dihitung ya. Ya, ini. Poltek Bang Surabaya, boys rek. Ya.
Kirain jawab.
Cadan me.
Cek. Sekali lagi. Iya, terima kasih juga Bapak. Terima kasih juga Bapak. Sekali lagi untuk teman-teman participants atau peserta dari Icateas 2022, mohon untuk berkenan foto dulu ya di foto booth. Tempatnya ada di sebelah kiri gedung serbaguna ini. Jadi setelah keluar dari pintu gedung serbaguna, bisa belok ke kiri, nanti akan ada panitia yang mengarahkan. Bisa foto terlebih dahulu di foto booth. Terima kasih sekali lagi kami ucapkan untuk seluruh peserta, seluruh tamu undangan yang sudah berkenan hadir dalam event pada pagi hari ini hingga siang. Semoga sehat selalu dan selamat makan siang juga. Untuk kawan-kawan yang akan mengikuti parallel session di Hotel Shangri-La Surabaya, sekali lagi diingatkan ya untuk foto dulu di foto booth di sebelah kiri gedung serbaguna. Nanti akan diarahkan untuk prepare bersama-sama menuju ke Hotel Shangri-La Surabaya. Ono yuyu nang tenggilis gede. Thank you and have a nice day.